Well, hello and welcome to SkyTour LiveStream for April 13th. It's the 13th. Unlucky 13, right? Well, maybe for the Comet. Welcome, guys, and thank you for your patience. I knew some of you were actually here ahead of time, which is fantastic. I appreciate that so much. You guys are amazing. I think David Byrne was here first, and then Chris Elliott showed up. Elliott Astro Imaging. He has a great stream that he does. So check out Elliott Astro Imaging as well, and subscribe, and hit the like on his channel as well. I want to say hi to D17 Tom, and I want to say hi to Daisy and Zoe, and Laura Newbert's here. Hi, Laura. How are you? Donald Kunzer is here, and Tim F. Woohoo! There we go, and Stacy. So you guys are just such regulars, you know. And Sean is here. Sean Hawkins, who's trying to do some solar observing, and that's really good. Just be very careful, Sean. You don't want to accidentally let any of the light through. The Daystar quark filter is great, but it's at the other end of the telescope where the eyepieces are. So where the eyepiece is, so you're going to have a lot of heat going into that tube. So you don't want to have a lot of heat. So what you do is you put the cap on, but then you have a hole in the cap you could cut that you could cover with tape or something. It may not look nice, but it will do a very nice job of keeping the heat down in the tube. So I'm glad you guys are here. This is the Orion Nebula, last gasp that we took a picture of here. This was a 1 minute exposure at a lower ISO, that is sensitivity. And I did it just because I wanted to see how the narrow band filter would work. This is the extreme narrow band, so we're only getting a tiny slot of the O3, the ionized oxygen, doubly ionized oxygen, a little bit of the H beta, and mostly the H alpha, which is the red, and the O3 is this bluish part here, this bluish green, and then the sulfur 2, which is in here as well. So these colors make up the narrow band imagery that we see a lot in astronomy imagery. But, you know, as we said, I checked the optics. We had some dew on the optics earlier, and I thought that could be a problem. So I let it sit for a while, and I turned on the dew heater. Well, actually, it goes on when the telescope goes on, no matter where it is. Even in Arizona, there's dew, believe it or not. So the dew heater did its job and got rid of all the dew that was near the center of the telescope optics. And so we will have some nicer views. I'm currently set up on Comet Atlas, and so I know you can't see much right now, and I don't know if we can see much, but I'm going to actually just do basically a finder shot just to make sure we have it. We'll do 20 seconds at 10,000 and see if we have it in the view. It's moving so fast now that it's kind of hard to make sure that it's there at all times. You know, it can move out of the view. It doesn't move through the view very fast, obviously, but over the course of days is what I'm talking about. I think I did 15 seconds. There it is. It's up here at the top, and what we're going to do is rotate the view so you can see it. It's up there, and we're looking at it in the narrow band, and what we're going to do is change that and look at it in white light. Because I think if we look at it in the white light first, we should be able to see it a little better. So I'm going to bring the view down and see what we can do. All right, let's try this. 15 seconds at 10,000. We're still in the narrow band. Tim F, do it. And by the way, everybody, I want to welcome Carol Carl, who is joining me tonight as the co-host of the SkyTour livestream tonight. Hello, Carol. How are you?
Oh, I am fine and so grateful to be here. This is really a joy. And hello, everybody. It's really good to see all these incredible names. A lot of them I'm familiar with at this point. But yeah, do it, Tim F. That's hilarious, right?
Isn't that great?
Yeah, it's wonderful.
Yeah.
Yep.
Yeah.
There are do's and don't do's, and well, you can't control that.
That's right.
Yeah, but wow. So there, I'm seeing it. Yep.
This is This is the narrow band view of the comet. We're actually looking at it in the light of oxygen 3, H beta, sulfur 2, and hydrogen alpha. So that's what we're seeing in it now. And I will change over to the oh, by the way, I got new music too, guys. That's probably what you're hearing now. So kind of exciting, a little bit new. There's gonna be some jazz in here too, as well.
Ooh,
so
very cool.
yeah, so it'll be kind of cool.
The SkyTour LiveStream Jazz Room, the lounge, right? Yeah, that's indeed. How perfect! How great that is.
Welcome
hey,
to
Marianne
SkyTour LiveStream Jazz. All music, all the time. And Marianne Robb is here. Hello, Marianne. You'll never take me alive, copper. I always say that to her. She's a police officer out in Arizona. Actually, she has been instrumental in helping coordinate getting SkyTour LiveStream West up and running. And if this ever became a corporation, she'd be one of the officers. I can tell you right now.
Oh, that would be so cool. I can see her. Yeah.
Well,
Would you have to have a change of costume, wardrobe?
I'm not going to turn it into a corporation. This is going to be a for fun thing, because I know that people really enjoy it. I really enjoy it too. I'm having such a good time looking at all these things. Now, what I'm going to do right now is I am going to change over to the white light view. All right, and that'll be this next filter. I'm hitting the arrow keys. For those who are unfamiliar, I'll just go through it real quick. This is the telescope control system over here. This is me. Hi there. I'm waving. This is the camera control cluster, and this is the observatory view cam. It's got infrared system on it and zooming and all that stuff. And pan and tilt, so we can move it all around. Then this is the main view. And incidentally, we also have a planetarium view that we also bring in. And when I do that, I usually get rid of this guy, so we can actually look where the telescope is pointing. So right now, if I turn this around, all right, you'll see that we have, the Big Dipper right here. There's the bowl of the Big Dipper and the handle. It's upside down, spilling out on us. And those two stars at the end of the Big Dipper's bowl point right to the North Star, which is here. So if you go about halfway between them and then go away from them by about the length of the Big Dipper itself, you'll see the comet if you have a pair of binoculars. And it's actually kind of faint right now. So it's neat. It is what it is, The comet is in the process of breaking up, which I believe we caught that. About a week and a half ago on SkyTour LiveStream, we actually caught the comet had several distinct additions to the nucleus that we caught. And I called them out and said, hey, look at those things.
You did, yes.
Yeah.
And you were saying that you had never personally witnessed anything quite like that before.
That's right.
And
That's
yeah,
right.
and it was just it was a chilling moment. That's all I can say. It was the drama was enormous. Because it was pretty much, even to my unscientific, untrained eye, it was obvious that something was up there.
Yeah, and that's correct. And what I thought was happening actually was happening, and I was like, wow, that is so cool.
Yeah.
Now, the other thing, too, is, and I'll get to taking pictures here in a minute, I got us on white light, and I'm going to probably have to refocus, because in white light, we need to refocus. So what I'll do is I will change this over to a focus mode, and you can see faint little stars there, and, the cursor is really big, when it's like that. But I'm going to bring that star that you cannot quite see. I'm going to bring that in because I want to have that star as the one I'm going to focus with. Oh, there she is. See it? Okay, so this is the star I'm going to focus on. No pun intended. All right, so here we're going to focus now. We'll see if we can pull the focus for this and grab it. Okay, that already looks a little better, but I got to go beyond it and make sure. Okay, then it's the other way, and we come back in. Okay. It can take a long time to get proper focus sometimes.
We're patient.
Oh, that's okay. I'm usually not. So I'm going to pop this way out. Okay, that.
Just listen to this new music.
Yeah, well, this is an older shot, shot of music right here. This one.
Oh,
this
really?
one cut,
Okay.
but that's okay. All right, so that's good. I think we can try that. Let's do another 15 seconds at 10,000 just to do this, and this will be a white light shot now. Hey there, Do. How are you? Do W is here. Do W's in the house.
Right. As opposed to dew on the lens.
That's right.
Yeah.
And Tara is here as well. Hello, Tara.
Hey, Tara. And Laura Newbert.
Laura Newbert, yeah. Yeah, here we go. So you see the comet now, and it has the nucleus is somewhat fainter now, and that's part and parcel with what happens when it breaks up. It starts getting distended. So as it's become somewhat brighter and gotten closer to the sun, it has begun to break up. It no longer has that distinctive nucleus with the tail. We can see the tail. I mean, there is a tail here. Okay, and if we actually look, okay, the nucleus was like here, right? And the tail now goes to like here, and it's a little longer. Okay, if you expose it longer, but that's it right now. Okay, and it normally should be a very bright center core followed by it should be a very bright center core followed by the tails, and usually there's two tails. You'll see an ion tail and a dust tail, and you can kind of see them both right here.
Yeah, you sure can.
Okay, and there will be a separation as it gets closer to the sun. Those tails will separate even more, and I think someone in the chat had asked how close it is now, and I do have that information for you, and I will dig it up for you right now if I can. First of all, it's going to be when it reaches what's called the perihelion point. It's going to be like May 30th or so, and that's when it reaches the closest point to the sun, where it's at its closest approach. Now, the comet is going to reach the closest approach to the Earth on May 23rd. And then that'll put it 116,859,502 miles kilometers in case you want to know, and it's about 73 million miles. So right now, the other night the comet was 1 astronomical unit from us, and so it took the light about 8 minutes to get here from the comet. And let me look at tonight and see how close it is. Let's look at the distance. Right now it's 1.00 astronomical units from us. It's actually still about that long, that far away. So it's actually about the distance that the sun is from the Earth from us right now. And we can see it pretty nicely, actually.
And that's striking. And listen, something to address. And by the way, Charles is in the house, and Papa Tom says, "Hey."
All right.
Molly
Hey, guys.
Woolhart. Molly is concerned that the tail of Atlas will destroy the Earth.
Oh, you know what? That Molly and Molly Walkhart. Thank you for coming.
Walkhart, thank you. Okay.
No, it's okay. I people used to call me Mark Dan Antonio and Dan Antonio. And,
Okay, well, I've been
so-
Carly my
yeah, so
half my life. So yeah, okay, go
So
ahead.
I tend to I'll make sure I get people's pronunciations right, and if I'm wrong, they'll tell me, and I'll honor that. I'll respect it. But just like you do. So as far as the tail of Atlas, well, the tail of Atlas won't be such a big problem for us, because if you actually look at how Atlas is going in its orbit, all right, the thing to understand is that Comet Atlas is actually going to be nowhere near Earth's orbit. So we're actually not even going to benefit from the potential meteor showers that we get from comet tails, which is where meteor showers come from. And let me see if I still have. I'm going to try some. Hey, look, I got it. So yeah,
Wow.
so this right here, this is the Comet Atlas Let me just do this for you guys. This is Comet Atlas in 3D. Okay, so the Earth is this blue orbit ring right here, okay? And you can see the purple, that's the Comet Atlas orbit. It's actually really highly elliptical. If you look at it, if we zoom way out, look at this. Okay, it goes way, way out. Okay, way, way out. And when I say way, way out, okay, that's Pluto right there. Okay, and Comet Atlas goes way out into the Kuiper Belt. That's its orbit. All right, so it effectively goes as far away from us as ever, and it's actually, its orbit takes over 6,000 years, 6,016 years to actually complete one time. So right now, here it is, and it's going to be getting closer to the sun, pass around the sun. It probably is going to break up fully in here, and then what comes out the other side, if anything, is going to be fragments, and we'll be looking for the fragments. I can tell you that. That'll be kind of fun. Yeah.
Oh, that perspective is fantastic.
Yeah, that helps a lot, because now you can see, you get an idea. Now that looks like it's just a small little ellipse, doesn't it? But as in astronomy, look at it, see? Okay, that little tiny circle becomes a very, very big, long ellipse. So yeah, so that is where it is. And if we look at the Earth, all right, see there's Earth, the blue ring. You can see that Comet Atlas has an odd canted angle to the solar system's plane, see? So when it comes through, we're not going to have any debris over here that reaches Earth. And I just want you to understand that's probably, and this was all for you, Molly. I just want to show you this. I wasn't going to do this, but when you said that, I wanted you to rest assured that wasn't going to be a problem, so I thought I'd show you. So we pass through cometary tails all the time, and that's what meteor showers are, all right? And we pass through the tail of Comet Halley, Halley's Comet. And in the late 1800s, Camille Flammarion saw that the comet was somewhat green, and it is. It looks really green, and so when we look at the comet, okay, in white light, we can't really see green too much here right now, but that's only because I didn't take a long enough exposure. But I'm going to now, and we'll see what we can do. I'm going to take I'll go double. I'll take a 30-second exposure right here. And while it's taking it, I'm going to come back. Actually, I'm going to increase the sensitivity over here too. So I have my ISO controls, ISO, or sensitivity of the camera here, and the exposure settings over here. So if we do take that picture, it's on its way now, and it'll actually pop in here, and at whatever magnification I set this to, like this, it'll come in at this level, at this amount, and I'll have to just rotate it into position. But this comet right now, the green color, and this goes back to what I was talking about with Camille Flammarion. Flammarion thought that because the green color represented the color given off by the glowing molecules of cyanogen, which is, and I'm going to just flip this now, it'll pop in where it belongs. Okay, now the green color is a little more evident, okay? And you can see that the cyanogen is responsible for a lot of this green color. What's cyanogen? Cyanogen is simply a carbon atom connected to a nitrogen atom, and that's cyanogen. And cyanide, of course, is very toxic to us. So Flammarion in the 1800s basically said when Comet Halley comes back in 1910 that he thought that if we go through the tail, that we would end up getting killed by the cyanide from the comet, and he caused one heck of a uproar. But it was an uproar for nothing, because the answer to that is no, silly. There's nothing like that that's going to happen.
Silly Camille, come on.
Yeah, silly Flammarion,
Yeah.
Yeah. So, Flammarion flamed out with this one, let me tell you. Okay.
Perfect.
And he basically had he couldn't live it down. It was just kind of tough. I'd be
One can
embarrassed
imagine.
too. What can I say?
Yeah. Yeah.
So
By the way, I just have to throw this in before it kind of disappears
yeah.
forever. Marianne thought it would be cool if you played your didgeridoo and recorded it and played it during this incredible Sky Tour.
Well, did she
I
know?
love that. Yeah,
Did she know?
I love that.
I have a collection of didgeridoos.
Whoa!
Many of them
I
I
only have
made.
one.
I
Okay.
made most of mine though. I got one from Australia, and I've never played didgeridoo music with jazz, however, but didgeridoos are typically one tone that you can exacerbate the sound by doing some vocalizations and changing the air cavity in your mouth. And that changes what's called the standing wave inside the didgeridoo. What is a didgeridoo? It's a hollow, termite-eaten log. It is. That's what it is.
That sounds so unromantic when you consider the sound that it's capable of producing. But wow. But yeah, okay.
And the sound it makes is, of course, that kind of sound.
Right. Very sci-fi.
Yeah. It's very guttural and primitive, and so I am a big fan of guttural and primitive Australian music. And why? Because the Aboriginal music is really, to me, the equivalent of the drums that people do drum circles here. Well, didgeridoos with these clackers are the alternative for Australians. And I have to tell you, you haven't lived until you learn to play the didgeridoo. You just haven't. By the way, just so you know, this is a star right here that the comet's in front of. All right, so as the night goes on, we'll see that star remain where it is, and the comet will go past it. Okay, it's going to go probably in like this direction, right like this. In fact, I would bet we could see a difference right now. Let me...
Yeah, it's a great gauge for us.
Yeah.
In terms of how it's traveling. Hello, Kathy. How are you doing out there?
Kathy Pernisek, hi there. How are you?
She is there in the house.
Yeah. Yeah. See, look here's the cometary nucleus head right there, and then the current picture we took. Look, it's now just to the right of that star, whereas it was before just to the left. See that? Dun, dun.
Wow.
Yeah. That's with that's 15 seconds white light. This is 30 seconds with white light. And I would like to take some shots of it. Look at the green, though. I think that green is just beautiful.
Once the eye gets used to seeing that as green, it's like unmistakable. I'm there now. I can sort of like I capture it, and then you mention it. So I'm very proud of myself.
Yes, of course, yeah. and you should say so. So yeah, so we've got a beautiful cyanogen coma around this cometary nucleus here, and we again and Molly, thank you for that question. That was actually a fantastic question, because it is something that is often thought of and thought about. And here at SkyTour LiveStream, there is no stupid questions. There are no questions that are out of bounds. You can ask anything you want, and we are not going to make you feel like you don't know what you're talking about, because you're here because you want to learn astronomy. And here's a little something that I think some of you already know. I knew I was going to be an astronomer when I was 9 years old.
Yep.
And I never wavered. I actually went on and said, I'm going to do astronomy. All the classes I took in high school were tailored toward doing astronomy in college. The classes I even took in junior high. Okay. And I was in third grade in when I was 9. And so I focused on the science. And by the time I was in 7th grade, I was borrowing school microscopes to learn about the ecology of the ponds, and to learn about the environments, and to learn about the earth science that had to do with the earth and the geology. I was in that because I knew that we were going to find planets around other stars someday. And to that point, we had not. But
wow.
I knew we were going to. And so I chose to follow that path. Hey, Axie, how you doing? Axie was here the other night asking some really great questions. Welcome back.
So Mark, you were both prescient and definitely precocious. I would say
I was,
those things combined, and we are
yeah,
so glad you are.
yeah. But see, when I was 9 and in 3rd grade, one of the problems was I was so precocious that the 3rd grade teacher couldn't handle me, and she didn't tell anyone, but sent me down to the kindergarten for 6 months of that year.
Oh, what? Oh my God!
I was in the kindergarten for 6 months out of the year in 3rd grade because I was so poorly behaved. And when my parents found out that she had sent me to kindergarten, they blew a gasket, and
Yeah.
the teacher was fired. And I, as a 9-year-old, I didn't know what happened. In later years, I felt bad because I thought, well, it was all my fault, this poor woman. I'm not saying it because she was a bad teacher. She was trying to be a good teacher, but some jerk in her 3rd grade class just wouldn't let her talk and was interrupting her and doing stupid stuff, and that was me. Okay?
And also, I just have to toss in and asking her questions that she could not answer.
Well,
I'm just going to guess.
Yeah.
Yeah.
Yeah. So, yeah, and so it was my fault, and I really felt bad for her, believe it or not. Even though she stuck me in kindergarten for half the year, I wasn't mad at her. I felt bad for her. Even as a 9-year-old, I felt bad for her. I thought it was terrible she was fired. I thought, oh, come on. She's starting out as a teacher. This is, as a 9-year-old, I didn't think this. Later years, I did. But
that's your heart. That's your heart. And before the question disappears, Laura Niebert, whoops, it's kind of gone. Let's see if I can get it back. Let's see if brain serves. No, it doesn't. And maybe I can manipulate this.
Have
Laura
I heard
had a
about
question.
the big asteroid near us?
Yeah. That's it. Thank you.
Yeah.
There we go.
Yeah, I can scroll back too. You don't have control of the screen, but
thank you.
If you tell me, I will.
Wonky there for a second.
Yeah, no. Laura. There's a few asteroids, but they're nothing that's going to endanger us. I'll tell you how it works. And we'll do it to the tune of this wonderful jazz music. The way it goes is when an asteroid is found, and the very telescope that we use that found this Atlas, okay, the Atlas telescope found this comet. The same telescope can find some asteroids as well, and the asteroid hunters will take an asteroid that they find for the first time, and they'll stick it on something called the Sentry List. The Sentry List is a list of potentially dangerous asteroids that could strike the Earth. So it's a first attempt at, in our early evolutionary history and technological capability to try and find a way to identify the killer asteroids if they're out there. And I think they are out there, but I think that we're going to have the capability of stalling them and halting a collision, because eventually we'll have a technique for altering their orbits. Now, there's already plans on the docket. Let's suppose an asteroid was coming right for us. All right? It depends how much time we have, how much lead time. So the sooner we know about it, the sooner we can organize a mission to get out to it, plant a few thrusters on its surface that literally make the fuel they need right from the material in the surface of the asteroid, and nudge that asteroid out of its existing orbit and put it into a safer orbit. If you're several hundreds of millions of miles away from the Earth, all right, or actually let's put it this way, if it's say 2 years from a potential impact to the Earth, you nudge it. You don't have to nudge it very much. The slightest nudge will actually get it to move enough. Now you land the thruster, you land thrusters and fire the thrusters. They'd have to fire for like 6 months, a year, whatever, straight. Okay. Well, then there's another one. Another possibility is creating a low yield nuclear warhead. All right. It does not disintegrate the asteroid, but it creates an impulsive force on the asteroid to do the nudge. Now, what that'll do, of course, is break a little bit of it away and cause it to, fragment a little bit. But the idea is not to break it into pieces. If it breaks it into pieces, then that would be bad. Hey, Lynch, how you doing?
Right, because those pieces would present an issue just like little smaller bits of asteroid. But if it breaks it up just enough to change the trajectory,
You got it.
the little bits are nothing to worry about.
That is exactly right. And
Okay.
if we can get away without having to worry about those little bits, then we should be in good shape. And that's the idea with this nudging program. Okay. I'm starting a 1-minute exposure on the comet to try and pull the green out a little more. Again, it's white light, so it's going to be kind of bright. Luckily, we don't have to worry about the moon. The sky's a little bit light tonight because we have some water vapor in the air. We had torrential rains all day today, literally all day. My feet are soaked from walking out to the dome.
My gosh.
Yeah, and it cleared up at the end of the day. I didn't think I'd be streaming tonight. I was like, I can't stream tonight. And then, of course, it clears up like this. And I'm like, wait a minute. Yes, I can. And when I set up the stream, and people started showing up, I was like, I'm gonna stream tonight.
Yeah. You just need a little bit of encouragement, and you are off. I know here in Southern California, it's been raining pretty steadily, and I guess there's about a foot of snow up on Mount Baldy. Which I can see from my upstairs balcony. Just a little. Oh, what's that, Mark? That line, Mark?
Oh, yeah, that's called a satellite.
Okay, that's what I thought.
Yeah, well, that's kind of cool. So that's a white light photo, and of course the satellite went through at the same time. And this is what happens, and it went right through the comet tail. See that?
Yeah, my gosh.
That's kind of cool.
So okay, now ignorant question here. However, as you said, there are no. Okay, this is how we learn. What satellite do you think that might have been? I know probably there's some sort of an app that could tell us, but I guess my question is, does the satellite realize that it went through the tail of the comet?
Well, the satellite doesn't know because it didn't actually go through the tail of the comet because this is in Earth. This is
closer?
in Earth. Yeah, much closer. This is in Earth orbit.
So we just have a perspective situation.
Yeah,
there. Okay.
It's superimposed. The comet right now is 93 million miles from us, and the satellite's probably about 300 or 400. So
big difference. Okay, never
huge
mind.
difference. Yeah, but see, in this location where you don't have anything of known size, you don't know how far away things are, and that leads to a whole bunch of conspiracies and all kinds of stuff.
Yeah, exactly.
Yeah, I want to just take a moment to say. Hello to Kimmy, who's here. Eugene Schnitker, how you doing? And Papa Tom, I think I said hi to you as well. Monorail is here. How you doing? Thanks for coming out. And I think I said hi to Axie already. Yes, I did. Charles, I probably sort of indirectly said hi to you.
Yeah, and I said hi to Charles. So
sure
it's so great to have all these familiar names.
Yeah, I know.
Showing up.
And
yeah,
a lot of new ones
fantastic.
too. A lot of new ones,
and new ones. See, exactly. That's to ever increase your outreach is superior.
Yeah, no, the outreach thing is a big deal to me because I want people to understand that science is for everybody and it can be freaking fun, man.
Right.
It can
and
be a lot of fun.
Non-discriminatory, indeed.
Yeah, right. It's like when I was studying astronomy, I had a lot of really interesting experiences, and one of which was when I was getting my degree in astronomy. And what's this doing here?
What? We're back in Christmas or forward in Christmas? Well, what do you know?
No, that's a errant song.
12 days of Christmas there. What? Okay.
Anyway, yeah, I was talking to my director of the observatory, and this was before the first exoplanet was ever found. And I said to him that I believe that it's a populated universe. And he looks at me over the top of his glasses. He was somewhat rotund man, and he was wearing suspenders. And he looks over the top of his glasses, goes, what are you talking about, Mr. D'Antonio? And I said, I really believe it's a populated universe. I think that there's a lot of other planets like the Earth out there, and who knows, maybe intelligent life as well. And he kind of rolled his eyes at me, and this is sort of the longer version of the short story that they tell. And he goes, oh, what are you talking about? He says, you're going, and he had a little smile. I don't know that he denied or doubted it. I think that he thought it was possible. But, in science and academia, you don't want to be saying things before their time. You want to be able to back everything up you say with factual data.
Yes.
And I only had speculative data. And I said, well, look at every life form on this planet. Every life form on this planet is carbon-based. The carbon atom is ubiquitous. Carbon-based life requires oxygen to do processing and to gain energy. So we have oxygen in our atmosphere. All we have to do, I said, is look for planets that have oxygen in their atmosphere.
Yeah.
And that will show us potentially that there is a life process going on that's generating oxygen there, so maybe life, sort of like us, could exist. We came out exactly the way we did because of 5 major extinction events that caused lots of changes in our evolutionary record and pathway. But still, I said to him, I do believe it's a populated universe. And that phrase, the populated universe, stuck with me for many years, and it became the title of my book, The Populated Universe.
Yeah. Yep.
Which is, I still,
so cool.
I still, publicly would like to invite you to, do the audiobook.
Oh, kiddo. Yes, indeed. And I sort of like, I'm all set up. I'm ready to do it. I simply have to just absolutely, screw up my courage, as it were, and go for it. Because I just, what I love so much is your sense of humor that you intersperse throughout the book, and it is so very readable. And I think I got your syntax, I got your rhythms, and I think this could definitely be a go. And I am, of course, so incredibly honored to even have this as an opportunity. Oh, James Dugan is in the house. He says,
James.
Good day. And
G'day,
there
James.
he is. Yep.
How's it going? We were talking about didgeridoos earlier, James, because
Yes. Yeah.
I make them here. That's one of the things I do. I even, and going back to digits for just a little bit, and then I'll finish the story about the director of my observatory. The smallest dig I have is about 8 inches long, and it's about 9 inches. No, it's 9 inches long, 8 inches wide, and about 1 inch thick. And it's sort of rectangular, flat, slabby looking. It's actually called a travel dig. And it's a didgeridoo that has a pathway that approximates around a 4-foot long distance that the air goes through inside the circuitous route, inside all of this. It's all wood. And it sounds like a larger didgeridoo. It's really beautiful. And I can throw it in a suitcase, and I can play the didgeridoo in Arizona and not have to carry a 25-pound, stringy bark log in a cloth bag onto the plane, because you don't put that in luggage, okay? You carry these are carry-ons, and they go like in a first-class closet or something.
Yeah.
So, and honestly, this travel dig is just so much fun. So, diges are great, and just because someone's from Australia doesn't even mean they play the dig or know about the dig. They probably heard about it. It's sort of cultural in a sense. But around here, I've played them for years.
I'm just gobsmacked with the idea of a compact dig that travels on an airplane. I mean, like who'd have thunk it?
I know.
It's the ancient and the brand new, and it's wow, how intriguing is that?
Yeah.
Mine is about, 4.5 feet tall in a woven kind of Aboriginal patterned bag, and comes from a local place called the Folk Music Center here in Claremont.
Okay.
Which the Folk Music Center, okay, the grandfather produced a daughter who produced Ben Harper, who is like, especially in Europe, Ben Harper is a very well-known recording artist with some gold records.
Okay.
And was married for a couple of years to Laura Dern, the actress. So yeah, grew up across the street from us. But so didgeries, and didgeridoos, and what is that song? There was an old song. Play me didgeridoo, boy. What is it? What's that song?
Sounds like Rolf. Was it Rolf?
Yeah. There you go. You're kind of. Yep.
Yeah.
Tie Me Kangaroo Down, I think was
That's
the
right.
title of the
Tie
song.
Me Kangaroo Down,
right.
Sport. Tie Me Kangaroo Down. Yeah, that was Rolf. James Dugan helped me out. Rolf's a famous folk music guy down there. I got in a little legal trouble. Actually, in recent years. What the hell is this doing again?
I don't know anything about. Yeah, here we go.
Here we
Well,
go
hey,
again.
listen. Actually, we can use that music to, forestall any worries that we're not going to have a Christmas this year. Oh, so there we go. Okay,
Yeah. No problem.
no problem.
So yeah, and so James will be thinking about it. Yeah, Timey Kangaroo Dinosaur or Lamey Kangaroo Dinosaur. But was it,
Lamey kangaroo.
is it
Okay.
Rolf? I want to say Harris. Well, it's not Harris, is it?
I
What's his name?
don't know.
Rolf what?
Could it?
Ralph
Okay,
Harris. I was right. Yeah, Ralph Harris. That's what I thought it was. Fabian says Ralph Harris.
I remember now. Tan me hide when I died. Clyde tan me. So he tanned me hide, and that's it. Hanging on the shed. Everybody now. Okay. So right. There we go. That's the entertainment moment for the evening, or not. Yeah.
Oh, Eugene says, "Hey, I should make a didgeridoo video." You know what I did? I didn't do that, but you know what I do? You know what? To make a didgeridoo, the first place you go, and again, it depends how much money you want to spend.
Right.
I don't have time to wait for termites to eat out some logs. Okay. So what I do is I go to Home Depot, and I walk down the PVC pipe aisle.
Oh my God.
And when I walk down the PVC pipe aisle, people think I'm nuts because I pick them up and I play the pipes. Okay, because they're all a little bit different. And
Yeah.
I have, the metal galvanized pipes that go for those fences, the metal fencing.
Right. Like the posts, right?
Yeah, those posts. Yeah, I play those too, and I have one here, and it has a very distinctively higher pitch, more treble in it. Higher pitch. It's really beautiful, and the only problem is you got to make mouthpieces for them, and for the metal ones, I actually just wrap them in duct tape and lots of duct tape just to get the compression.
Absolutely. Yep. Tape. I was thinking. Okay, so no, you need to at some point, I'm lying on you to finish that story about your professor.
Yeah, I'm getting it there.
Okay.
So,
all right.
Any case, when I was trying, and I'm actually about to change to another filter here. I'm going to go to rolling through the filter wheel here. Okay, this is narrowband. This is the wider version of the narrowband right here, and it cuts out some light, so we definitely want to go for a minute here. So here we go. So when I talked to the director of my observatory, I basically said to him that I believe it's a populated universe, and I said the reason that I think it's so is because look at all the variety of life we have here on this planet. There is life of all kinds that is eking out an existence in many different ecosystems, some of which are incredibly hostile to us and our way of life. There's life forms that cling to the walls of active lava lakes right above the lava. Okay, bacteria.
Right, extremophiles.
Extremophiles, yes. There are creatures that live within the hot Yellowstone National Park geyser hot springs, mineral-laden, bacterial-laden. Okay, so those extremophiles tend to be microbial life. Okay, and that's fine. It's life. However, if we that's pretty. I got to change the focus though. See, because I changing the filter, I got to use the alternate focus. So, but the thing is, and I'll do that. When we look at the fact that extremophiles exist, we notice that in all the cases, all the life from the extremophiles to the very fragile forms of life, all of it has something in common. They all have one thing in common. At the very least, that's DNA. They have carbon atoms throughout their systems. They use oxygen to manufacture energy, except for the anaerobic type stuff that doesn't use oxygen, okay, the bacteria. But for the multicellular creatures and larger, higher forms of life, it's all about carbon atoms. It's all about oxygen being used to create energy for the creature. So it's not like it's something that is, what's the word? It's not like it's something that is it's nothing that's actually something we can identify as a very tangible element, okay? In other words, it's carbon, all right? And the carbon-based life on this planet, all of it, okay, all the carbon-based life on this planet has an interesting symmetry, all right? And that symmetry is very important because that symmetry is something that makes carbon-based life all the same in terms of how they interact with their environment, all right? So when we look at creatures, for instance, that are living in, say, the Serengeti, and they're creatures that are actually, meerkats, for instance, living out there. When we look at lions, when we look at a platypus down in the southern hemisphere, we look at whales, we look at dolphins, we look at fish. Every single creature has DNA. Just a different set of nucleotides, all connected in a different order to form the DNA message that's meant for that particular form of life. So that, and I was talking to him about this, I was telling him this and saying, DNA is very important because the building blocks of life are what DNA is made from, right? It's CHOMPs, CHONPS, N is in November, okay? Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. That's CHOMPs, and that is what DNA is made of predominantly. And I'm doing a focus thing here, by the way, so you can tell.
Okay.
So when we talk about that, we have to think about how does DNA, how could we expect DNA would be propagated throughout the universe? Is DNA something that the universe is manufacturing? Is DNA a template? And I believe that DNA is indeed a template, as is carbon-based life. Why? Because comets have struck the Earth in the past, and hundreds of millions of years ago, and billions of years ago. Actually, maybe even Tunguska, in modern times, so to speak, and delivered carbon-based compounds to the planet, building blocks of life. Asteroids and meteors have delivered these building blocks of life. We had a meteor strike the Earth that brought amino acids to the planet. And the amino acids, I'm focusing so you can see that star right here, just getting a little bit more shapely. And amino acids are the building blocks of life. And they are delivered here by things like comets and meteors, asteroids, as is water. So you see, we have a tremendous wealth of materials that were delivered to the planet. We also have the Earth itself making a lot of these elements as well, and that's something that's interesting. There was an experiment done in the 50s called the Miller-Urey, U-R-E-Y, Miller-Urey experiment. And the Miller-Urey experiment was designed to see if a primordial atmosphere of compounds like carbon monoxide and other things that were, here in the primordial atmosphere at the time, could eventually somehow make the building blocks of life, complex hydrocarbons and so forth, and then amino acids. So the experiment was a sealed system, and they actually took in this sealed system, they actually hit it with lightning, basically a spark gap that was causing this. And this spark gap generated precipitate, this brown sludge that accumulated at the bottom of one of these flasks. That brown sludge was amino acids.
Wow.
So in other words, Earth itself also made the building blocks of life. Okay? And so if it happened here, then we know that it would happen elsewhere. And that is why I was so adamant and said, hey, I think the building blocks of life, that's better.
Yeah.
I think the building blocks of life are being manufactured or at other planets, and I think that our symmetry that we have, all the higher forms of life on this planet, have bilateral symmetry. They're the same on the left and the right, outwardly, for the most part. There's minor differences anyway, and that similarity is how they interact with their environment. All right, that bilateral symmetry. So it's not uncommon to think that if you see an alien here on Earth from another location far away, it's not uncommon to expect he won't look like us. It's also not uncommon to expect that he'll be something that maybe walks on two legs. And that's because of the fact that this bilateral symmetry, I think, is a pattern, a template provided by the universe. Maybe it's based on how DNA replicates, because when DNA replicates, you know how DNA is. It's a double helix. Okay, it's one spiral and another spiral that is a complementary spiral to it right across the center of the spiral, right? There's another one on the other side. Well, it unzips. And it becomes RNA, ribonucleic acid, and then it goes off to a cellular location where it then is duplicated. Well, that's going to be a symmetric duplication. So maybe at the micro level, the duplication that we see is the same type of thing that happens at the macro level when we see creatures that are created that have two eyes, two hemipheres of the brain.
Exactly. I was thinking about that two eyes thing, except for an octopus. We both, we all have two eyes, most life forms. Yes.
Yeah. There are creatures that live in perpetual darkness that had two eyes that have evolved away to just having
blind cave fish, for instance. Right.
Now they have just light receptors. See, now what is that? How did that happen? Well, you don't get that in one lifetime. It doesn't happen. I'm going to take another picture here. In one lifetime, okay? That doesn't happen in one lifetime. What happens with that is an example of evolution, all right? Mutation is what happens when one cave fish is born without eyes or with lesser quality eyes. Now, you might say, well, why would that ever happen? Well, the way it would happen is because we see this all over the place in nature. Maybe it's the ultraviolet radiation from our sun that's striking all life forms. Maybe these life forms are mutating genetically because of it. And I got to focus again. It goes out as the temperature changes. And so if it does mutate, okay, then if that mutation is something that can help it to survive better than the previous iterations, then that one will be automatically selected for success. And that's what happens with these mutations. That's why when we see a mutation in nature, it's so interesting because we know that we're actually watching evolution in progress.
Wow, yes. And circling back to evolution in progress, outside of being, perhaps the basis for a science fiction plot, etc., Tunguska, do you think there was any sort of an effect, long-lasting effect on DNA as a result of Tunguska?
I don't think we can tell right yet. I don't think so. But
so it would be too early.
Yeah, because we have to measure that in hundreds of thousands, if not millions of years. Although I know that genetic changes can happen in a couple of generations. So it's not a bad thought to look at that possibility. But we'd have to know what to look for because there's so many mutations that occur all the time anyway that it's really hard to actually, figure out what to look for,
Right. Okay. Thank you. Yeah. Okay.
Yeah, and I know that's sort of like not a good enough answer, but...
Well, no, but I'm not sure it was a good enough question, actually.
No, it was a good question. It was a very good question.
Right. Thank you.
So I want to see who else is here. I think, okay, we have... Tammy. Tammy's here. Hi, Tammy. And Monorail, I think I said hi to you as well. It's good to see you guys here. And I saw somebody else that was here that I had not said hello to. Genghis is here. Hello, Genghis.
Hey, Genghis. Genghis Khan. Great
Yeah,
name.
it is. He's one of the great Khans.
Yes, exactly. As no, and
Not
opposed to
C-O-N.
con artist. Yes,
Yeah.
right, exactly. K-A-H-N. Right. Yeah, it's all in this
Yeah.
spelling, isn't it?
Yeah.
Mm-hmm.
Yeah. So I just want to say hello to the guys that are here. That's really nice of you guys to join and hang out with us. We really do have a wonderful time here, and I love having people join us for the first time too, and they kind of learn to see what we're all about.
Right, here's Tammy. I can't quite read your last name, Tammy. It's very, very tiny print on my screen, but Tammy, and that's a name. Do I not recognize that name, perhaps?
Tammy Sublet.
Yeah, Tammy Sublet. There we go. Hey, Tammy.
Yep. All right, I'm going to go 30 seconds here. Now let's try this focus. I think I got a little better focusing done here.
Cool.
Yeah. Yeah. So tonight we're looking at Comet Atlas as it has been breaking up, and we've been watching it travel across the sky. Over previous nights, the comet has had a fairly, I should say cohesive-looking nucleus. But then when a comet starts to break apart, the round nucleus then becomes less round and it starts to become more elliptical, and that's kind of what happened. That's kind of what happened here, and you can see here, and now you can see that it's really past that star. When we looked at it earlier, let's see. Let me see if I can get another shot of it.
While you're getting that shot, I'll just, David Schmidt reminded the people the other night, or was it me in response to him saying Venus, et cetera, breaking up is hard to do. That very, very old song. So, yeah, but in terms of comments, that's true, correct?
Yeah.
I mean, it doesn't, and I have a question. How is there any predictable pattern for comets in terms of when we see them on Earth? They break up at point XYZ, blah blah ABC. I don't even know how to frame this. Is there a longevity of comets?
I know where you're going. I know where you're going.
Okay,
with this.
Thanks. Yeah, thank you.
You're basically saying, at what point in the comet's orbit could we predict its breakup if it was going to happen? To understand that, we would have to understand what the comet's actually made of. We know from looking at the spectrum, of the light coming from the comet, we can actually identify, for instance, carbon monoxide, which is a carbon atom with an oxygen atom, CO. Cyanogen, which is carbon with a nitrogen atom, CN. Okay, and various other ices that are on the comet that end up getting that sublimate and go right from the solid to a gas, and then we see them as they as the dust lights up here, right? And then we see the atoms glowing when the sun's ultraviolet energy ionizes the carbon molecules, atoms, and then when those electrons rejoin the atom, because ionization is when electrons are driven off of an atom. When the electrons rejoin the atom, they go to a specific locations in the atom, and they give off a specific color. When we look back at the Orion Nebula earlier, for instance, okay, here it is. The Orion.
Oh my God!
Yeah, the Orion Nebula. I took this picture before it set, guys, because I wanted to show it to you. This was a narrowband photo. This red part is hydrogen gas, right? And it was ionized. Hydrogen has one electron. Well, that electron's kicked out. Okay? And when that electron rejoins the atom, and it might not even be the same electron, but when it rejoins the atom, as it drops to an energy level within the atom, it drops to a specific location. We call it the N equals 2 level. And when it drops to this N equals 2 level, it gives off light, and the light happens to be reddish. Okay? Now it gives off other kinds of light too in different colors, but the red transition to that N equals 2 level is the predominant one. And that becomes this hydrogen alpha that we see, this reddish color. Then we have this blue here, this bluish teal color. These are oxygen atoms. that have been ionized doubly. So in other words, 2 electrons driven off. Okay, and when they rejoin the atom, they will typically give off this bluish green light when they do this transition back into the atom, and that's what this is about. And it's happening all the time, ionizing and recombining all the time. So
Okay, I have this very ignorant question. The ionizing, recombining in terms of our time here on Earth, minutes, seconds, years. What are we talking about here?
well, it's happening. It's happening all the time within split seconds.
Aha,
Okay.
split seconds. Okay. Thank
so
you. Yeah,
it's a
thank
constant process that's going on. This is a very very well, hot location. All right. You think the nuclear reactor is hot, with radiation. The stars that are causing this nebula to glow like this is light years across.
you. My God.
So we're talking about very, very hot stars in the middle that are causing this, okay?
Yeah.
And those stars, of course, are the trapezium stars, which are those 4 hot stars in the middle here that we've seen so many times in SkyTour LiveStream. And they're very hot young stars. And so they cause ionization for light years of the gas, you see? So that kind of thing is going on all the time. So when we look at going back to the comet now, we come back to our comet, and we notice that it has this bluish color, this greenish blue color. Well, that greenish blue color is directly related to the carbon atoms that are being ionized, and then the electrons recombining and giving off a characteristic green light predominantly, among other kinds of light. So everything in the universe is excited by ultraviolet radiation and other forms of radiation, and can also cause there to be light given off like this by having electrons that go back into the atom if it's an ionization process that causes it like this. And so with the comets, we see that. Now here's an interesting thing. When a comet passes in front of a star, like right here, this star is kind of the comet is way in front of it, of course, and the star is behind it. So the starlight coming through, if we took a spectrum of that star when the comet was over here, and took a spectrum of that star when the comet was here, we'd see a difference. The star's spectrum would be contaminated by the lines created by the chemistry that is in this coma cloud, and we'd see lines in the spectrum that correspond to the different types of materials that are in this comet. We can also just take a direct.
And would that be a measurement of gases, etc.?
Yeah, it would be a measurement of the composition of the gases.
Okay.
What's it made? Is it cyanogen? Is it carbon monoxide? That kind of thing.
Right.
So, that's a typical thing that we'll see. And I have a spectrometer that's coming, that's going to be integrated into the observatory somehow. I got to get it to work. It's not going to be here for another week or so, but it's something called a slit spectrograph. And right now, in the filter wheel, location 5 has nothing, so it's a straight through run. And we would use that with the spectrograph. And we'll be able to look at things like comets and look at their spectra, and we can sit here in SkyTour LiveStream and determine what the comet's made of by looking at ourselves right here. We can do real science, and I'm
in live time.
Yeah,
my God.
Exactly, in real time. Yep.
I love it.
I talked to a guy that wrote a spectroscopy program. His name is Tom Field. If you're interested in looking at his software, the software is named RSpec. That's the letter R followed by SPEC. RSpec. Tom Field's a friend, and he did a really nice job on this software. And it allows you to take in imagery that you create with a spectroscope like this and look at the spectrum and then figure out all these things. I think it's really cool figuring out the composition. It's kind of like, adding some real science to the fun. You know what I mean?
Exactly.
Yeah.
Yeah. Because I mean, come on, this is definite fun, but it's a learning tool. It's the addition of a learning tool.
Yeah. Yeah. So anyway, when we, you remember on NPR there was a show called Car Talk with Click and Clack, the Tappet brothers.
Yeah, exactly.
My brother Tommy, right? That remember that?
Couple of guys, yeah, right.
Well, this isn't Car Talk. This is Comet Talk, and I stole that from Gabrielle Fion in the chat. Gabrielle said that. And I like it.
Well, it's perfect.
It is.
Absolutely. Leave it to a French woman. Indeed. Yeah.
Well, yeah.
That's wonderful.
It's pretty cool.
Yeah. It's absolutely perfect. And I mean, that's the other thing is that you make this so accessible that there's no like sting to asking a question that is there are no stupid questions.
No, not at all.
Yeah.
You know why? Because I've asked them all. I've been that guy. Look, I'm not afraid. I'm not afraid to ask questions. when I was getting a degree in astronomy. You think, oh, well, you know so much about astronomy. You got to know everything. You want to bet? Astronomy changes our lives every single day. Things are happening all the time that change. We didn't think we'd ever see gravity waves. When black holes collide, they give off gravity waves.
Yeah.
We never thought we would see them because Einstein thought we could never see them. Yet we saw them. And then we learned that seeing these massive collisions helped us figure out a few things about the universe we didn't know. We also didn't know about some of the differences in what the differences meant between the time these signals arrived. Then we see what are called FRBs, fast radio bursts.
Right, exactly.
These are millisecond-long pulses that come from very, very far away galaxies. And the fact that they're coming from such far away distances means that at the source, the signals must have been absolutely mind-bendingly immense in strength.
And do you think that also implicates that they were targeted?
Well, I don't think so. I think that there's a natural explanation for what could be causing them. So, yes, we would like to believe they're in artificial intelligence. Oh, I see weird guys here. Hey, weird guy.
Hello, weird guy.
So
there's nothing too weird.
Yeah.
Okay.
Now I want to just get to a question Charles asked. I don't know if you can read the questions at all. But
No, it's very tiny on my screen. We'll work on that for next time. Yeah. Okay.
And Charles asked, do comets make a limited number of passes through the inner solar system over millions of years? Well, comets by their nature are deteriorating objects. They will deteriorate. For instance, when some comets pass, they are brilliant, and we call them apparitions. When they have a certain apparition that's brilliant, the next one may not be so brilliant. The one after that, maybe less so, and on, because as they approach the sun, they're evaporating a lot of their material. And they don't get it back. It's not like they go back out in space and get more stuff. I mean, they have what's on them since the formation of the solar system. So when we're watching a comet deteriorate like this one, we're watching the death of an object that's been here for 4.6 billion years. Wow. And the material that you're seeing, courtesy of the SkyTour LiveStream telescopes, this material coming off these comets, like this comet right here, okay, with the stars in the background there, this material coming off is material that was on the comet for 4.6 billion years. And then is now off the comet, never to return. And the comet is accelerating toward the sun, leaving this material behind forever and ever. It's really sad, to think about it. These glorious, amazing images and speedsters of the inner solar system as they come whipping through. They end up getting destroyed over long term. So it's a very good question, Tom. Very good question, Charles.
I have to just like, silly me, but I'm like tearing up here. And so it's, a kind of a substantiation to hear you say that it is kind of sad.
Oh yeah.
Yeah.
Well, don't forget, astronomy is science. Astronomy is romance. And astronomy is beauty as well. And you can't do the science without the romance and without the beauty. If you can't appreciate, it's all three. If you can't appreciate one, then the other two falter. You literally have to be able to see the beauty, understand the romance, and the long-term meaning, and then the science too. It's a three-part science to me. Three-part. It's a philosophy as well. Okay, so I would say that in my view it's really what it is. It's the science, the beauty. All right, and then the romance of this.
And that is what you offer. That is the absolute tasty part. It's hardly dry. It's hardly what a lot of people consider science to be. You seem to see the majesty and put it out there in poetic terms, if I say so.
Yeah.
And thank you.
I try, and I'll say one thing. When we look at objects in the night sky, okay, like for instance, earlier tonight before I actually started, I did image the sky, the Orion Nebula, before it set, okay, because I wanted to show you guys what it looks like, in the light of a narrowband filter and how that works. You can see much more cloudy detail in here than ever before, if you recognize it. But an object like this, for instance, it's changing all the time, but it changes at a scale that's beyond the human lifetime, so you really can't see too much of a difference. Now, when something dramatic happens, then that happens fast, like a supernova. Now, when we look at the constellation of Orion, and I haven't even brought up our planetarium system tonight, really, but if we were to actually come back here, and let me bring this up for now, just a minute. When we look at these stars, we're looking at a snapshot of the universe, the snapshot of our local universe right now. Okay, if we zoom in, actually, let me just first do this and make it a little easier to view here. Something ain't right here. Something happened here. So, let me bring this over. Oh, I see what's going on. I got myself messed up here. What happened?
Oh, no.
No, it's okay. I'll fix it right now. There we go. Okay. So, yeah. So, when we look at our local universe and we zoom in, and I'll just add a little bit, a little more interest here. We zoom in and we see all these stars. They're all moving, and not just because the Earth is rotating. The Earth is rotating for sure. And so when we look, okay, you can see that star right there is moving. Well, it's going down.
Oh, yeah.
Because it's heading toward the horizon. Okay, and when we look at the horizon, all right, we pull away, all right, and you see it's rotating around the pole. So when we see all that happening, okay, it's going this way around the pole, right? Because the North Star's over here, so it's going this way. And it goes this way, all right? And so they're going to appear to be going down. If we look at the western horizon, they're going to be doing the other thing. But this motion that we see is all because of the rotation of the Earth. So that tends to hide you, or hide the overall motion of the universe from you, because we just see the motion of the Earth. But if you actually leave the Earth and look out into space, you'll see that every single one of these stars is actually orbiting the galaxy as well as we are.
Oh, wow.
Yeah. So here's something for you. We have been going around the galaxy ever since our solar system was formed 4.6 billion years ago. And that trip takes millions of years. And we've done it 19 and a half times.
Oh my God.
These are the scales of the universe, you know? These are the scales of the universe.
That staggers the imagination.
It does indeed. It staggers the imagination, and it staggers many people's minds. Yeah. Isn't that cool, though? Yep.
Oh, Mark, you are such a boon to so many people. It's that staggers the imagination, and thank you.
Oh, well, that's okay. Now we're gonna take a break from the comet tonight for a moment. We will be back, okay? But I would like to take us to something else so that when we come back, we can compare the motion of the comet.
Cool.
So now we're gonna go to an object that's 12 million light years away. All right, and
Okay, buckle up, everybody.
yeah, buckle it up, because we're traveling to a galaxy here that we've seen before. This is Dubé. Actually, I can tell by the 2 stars. It's the N star in the Big Dipper, I believe. Yeah, see right there. Telescope is moving to Dubé, and then it's going to use Dubé as a resource for knowing the distance or location exactly of Dubé, and therefore it knows exactly where this galaxy is in relation to Dubé.
So it's the guide star.
It's high precision pointing that I now use with the telescope, because this telescope has a lot higher base power than the previous telescope we had in the observatory. And there we go.
Zip.
And now we're coming down, and you'll see the telescope crosshairs bring us down to this location right here. Here they go. And then when we come in here, you can actually see there's a little star here that's moving as we get set up. And we are in the wider band of the narrow band filter. And that's good. We want that. All right. So now what I will do is I will just do a find shot, make sure that I've got it. I'll do 20 seconds at 16,000. Then I'll set up for a more proper shot of this galaxy. When we talk about galaxies, we're talking about how the stars orbit the galaxy. This particular galaxy, you can't really tell which way things go in this galaxy, because something odd is happening here. Namely, there it is right there. The oddity that's happening in this galaxy is that it's actually got itself a really strange appearance, and that strange appearance is based on the fact that there is this red area in the galaxy right here, this very bright red patches, and then this hot blue area here. These are all young stars. This is a gigantic, like an Orion Nebula, except almost the size of a good portion of the galactic size. All right.
We saw that last night, right?
We did, and I'm just going to move us over to it again. I should move us, bring it up a little. Yeah. I figure why not? It's right nearby. It's right nearby. And I think that's a good thing. All right.
No masks required.
No masks required. And let me drop us down to... actually, I want to do 8,000 for 20 seconds on this. I'm bringing down the sensitivity, because when you bring down... There's a certain magic set of values, a magic exposure and a magic sensitivity that you reach, and that magic number can show you more detail. And I didn't write down what the magic number was for this, but I do know that I found one, and it was really, really something.
That would be like the Goldilocks number.
Yeah, and
Okay.
it would have been good if I had actually not moved too far, you know? But I did. I moved too far, and I got to go back now and bring it back in. Let me see what happens is the telescope sometimes reverses itself.
Oh.
So which way did I go? I think it went that way. So now I'm going to go this way. All right. So let's do that. And we'll take another 20-second shot. See if I got it back in. Well, so what happens is the telescope sometimes flips it upside down. And when it flips upside down, it changes the orientation of the image. That's the camera that's doing that, not the telescope, the camera.
Ah, and that's just something it kind of does on its own?
Yeah. So, okay, this is the companion galaxy that I was going to look at next. Okay, this is actually M81, all right? And M81 is a true spiral galaxy, which is really, really pretty.
Am I correct in assuming that M is as in Messier?
You got it.
Okay.
You got it, Carol.
See, I'm learning.
Yeah, you are. You are. And now what I'll do is I'm going to take us up with this one, and I'll set us to 30 seconds at 10,000 and 12,500. Now go to 30 seconds. All right. And then I'll go back to Measure 82, the Starburst Galaxy that we saw before I came here. Lynch, yeah, the M82, the one that we had earlier just a moment ago, was a Starburst Galaxy. Right now we're looking at M81, which is actually very close to it physically in space. All right, M81 is here, okay, in the sky, and M82 is here. M82 is 12 million light years away, and M81 is actually 11.8. So they're almost the same distance, and they're actually very close to each other in the sky. All right, so here is M80. Let me make sure that it's the right way. So now if you look, you'll see the spiral arms here of this galaxy. You can actually see these spiral arms here of the galaxy very, very clear. You know, there they are. Right?
Dramatic.
Yeah, and it's very dramatic. And if we take a deeper photo, then the colors become even more pronounced. I guess I could dare to do that and then come back to this photo for a minute, I guess.
Oh, give it. Yep.
Yeah, I can do that.
Oh my God, there we go.
I can do it. Hang on. All right. So let me give us a minute on this one. All right. There we go. And now while we're doing a minute on this one, we can talk about it. So this is a nucleus of the galaxy. You'll also notice that when you look at the nucleus of a galaxy, it kind of looks like the nucleus of a comet. It looks similar, but they're not the same in any way, okay? This nucleus,
it's that fuzz that is kind of the fuzzy part is that's the similarity.
And it's so much and it's so much further away. It's millions of light years away. This is impossibly bigger than a comet, you know. But in the sky, superimposed, a comet could be bigger than this whole galaxy looking, but it really isn't, of course. If the comet was at the same distance as the galaxy, we wouldn't even see it from Earth and couldn't even have a hope to see it from the Earth. All right, so that's how that works, right? So let's see now. We should still be exposing because we're doing a minute, right?
Okay.
Yeah, there we go.
Wow. Oh wow. Oh my God.
So now you can see those spiral arms a little better.
Absolutely.
Yeah.
Definitely. There's more definition.
There's
for sure.
much more. Yeah. Oh yeah, it's really pretty. Now, what I could do is if we go back to our view here, I could take us down another path where I could go to our white light only. This is the spectral reading, not the spectrometer, but the spectral grading that I have in there. Okay, and the next one is, this is white light. Now you can see more stars show up when we have white light. Let's do another minute at 12,500, or 800 rather, 12,800. And now you'll see it in true color, because we're seeing it.
Oh,
We're seeing
oh my
it
God.
this is the light of the filter right now, but in true color, after a minute, we'll actually see it come in. The sky will be brighter. It'll look like one of these shots that we took earlier, okay, of the comet.
Yes,
All
right
right.
down there at the
So
bottom.
it's going to have that kind of that weird haze to it, that weird look. But we're not going to have to deal with the moon, so that's good.
Yeah.
So in just a few seconds, that'll come in. And I just want to take a moment to, again, say thank you guys for coming out and checking us out. I'm really grateful that you find the SkyTour LiveStream to be worth it. Keep in mind, this is just a sort of a precursor to much, much better skies in Arizona, okay, that we're going to have. Here's the white light version of this, okay, and you can actually see now it's got a sort of a yellowish haze in the middle and more of a blue color on the outside. That's because in a galaxy, a spiral galaxy, older population stars, population 1 stars or population 2 stars are here, and the younger stars are on the outside and they're blue. All right, and the younger population of stars are formed in the spiral arms. Okay, and when you look in here, you'll see that the predominant nucleus of a galaxy is going to be sort of a yellowish older stars. So the blue ones are on the outside in the arms. So that's what these white light photos are good for showing. All right, so that's kind of cool, and then we use our filters to create a lot of detail, and then when we stack, we bring this color back. We bring back the right color to make the galaxy show properly. So that's interesting how that all works.
It's just I mean, it is mind blowing. It is absolutely exceptional, and to think that we're seeing this in real time.
That's right.
That's the other part here.
It is
so dramatic.
It is real time.
This isn't some documentary that was shot blah 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 time ago or blah blah. This is now, right now, and I'm thinking what an incredible opportunity since we are all sort of shut in and everything is shut down.
I know.
That this is an incredible beauty that you are offering everybody, Mark. That the idea that we can get a perspective that there's it's more than just Earth. There's a greater thing out there.
Oh yeah, I'm a big fan of the greater thing that's out there, as people know. Yeah. Yep. Yeah, I mean, and like I said, we're looking at things that are really interesting, and there's a history to them. I'm just going to do a finder shot here to make sure that I am back on it. I think it's gonna be in the view here, but I just have to make sure before I do the next phase of this. So there we go. So this is a white light.
God.
Yeah, this is a white light shot of the galaxy. So you can actually see the true colors of this Starburst Galaxy. Isn't that beautiful?
Wow. I have no words. It's absolutely unreal. Again, it looks like science fiction.
Yeah. Yeah.
Wow. Well, what would you say is the reason for the very red and then the path in between that's dark and then the blue or blue-green?
Yeah.
What makes that up for the unscientific mind?
Yeah, no, sure. This is in terms of what's going on here. This galaxy has had some type of interaction with the other galaxy we were just looking at. Mm-hmm. Remember when we looked at the planetarium shot here, we're looking at the fact that these two galaxies are very near each other in space, and they actually interacted with each other at one point. And this galaxy passing close to this galaxy didn't affect this one so much, but this one ended up having a burst of star formation, which is what we're seeing here. And so it's called a Starburst Galaxy. There's a lot more detail that the Hubble Space Telescope was able to show here, okay, that we can't show tonight because you can only see it from space. And this galaxy has these really long filamentary structures that stick out and that really kind of give away the fact that M81, the previous galaxy we looked at,
Right.
the regular spiral, had something to do with this. These reddish spots are areas that are stellar nurseries. Now, in white light, you can see there's like 1, 2, 3, 4, 5, and then there's several others here that are in the blue. That's because there's most likely a lot of red areas inside this galaxy, but some of them are shrouded by the massive blue, what are called OB associations, O stars, B stars, very hot and blue, that are masking a lot of that, right? You can kind of guess that there might be some built into this. This isn't all there are. So this is star formation regions, and the blue stars all represent, again, young hot stars. And in the outer reaches here, M82 is very blue, just like M81 was blue in the outer reaches. Now, if we're seeing this probably like edge on, if we look down on top of it, then we might see something that looks a little more like M81 maybe, but with some differences, including, as Charles Smar just offered, the possibility that the galactic disk is warped. And you see how it goes up like that, and then down, and it kind of curves? It's actually warped a little bit, and that warp is something that is, well, it's something that we see in some galaxies. It kind of goes like this, right?
Okay.
And that warp is something that indicates that we had something else going on here. Right?
Charles has an amazing brain. I just want to.
Oh yeah. Charles has an amazing brain.
Absolutely.
Yep. Charles, your brain is amazing, Charles. Wow.
We should put it in a jar, Charles.
Okay. He has a great brain.
Yeah.
May I take his brain now?
Yes. No, let him have it for a few more years. Okay. But wow. Okay. Oh my God. Yeah. But back to reality, or the reality of the cosmos. This is fascinating. The separation right where your arrow is, or your cursor is right now, Mark, and that. What do you call that? Would that be called a path, a lane?
It's right. It's a dark lane.
Okay, a dark lane.
Yeah.
Okay.
Now, when we went back here, let me go back to this real quick. You'll notice that this was only 15 seconds at 10,000. Okay, so I'm going to drop this down to 10 seconds. All right, for 8,000 at 8,000 ISO. All right, and there's a reason why, because when I take this picture now, we're going to actually see how the exposure makes a difference. Okay, again, we're in white light.
Right.
So when you take this exposure now, this might not be as dark, but you'll see the modeling now, see? You can actually see this modeled structure in here that you did not see in this previous exposure, because it's just a little bit too bright. So by cutting down the ISO, we can see more detail. We don't get as much noise. See out here, and we don't see as much noise as we do here. There's more spots and more red patchiness, but in this one at 8,000 there isn't. So ideally we'd like to do the lowest ISO and the longest exposure we could. So you see now how this looks. It's really a fascinating look at the galaxy. You can see a lot more of this spotty, knotted up areas within the galaxy. Okay? And we will lose some of the edge of the stuff here, okay? But still, we see a little more detail. And if we go back again, and let's say we drop it down to, say, 3,200, okay? That's 4 stops, okay? And then we go up to, say, 25 seconds or 23 seconds. We'll do 25 seconds. All right. Now we should have a picture that is the same because those are directly related to each other. You go down one on exposure and one up on the ISO, and you get identical shots. But what's different is the next shot we're going to come in is going to look like this, but with less noise still. Okay, there'll be less noise. If the 25-second shot looks good. All right, and there we go. And now you can see in the 25-second shot that it looks cleaner. It looks better even than this. This is the other shot, and you see there's more noise in here. Then we look at the 25-second shot at a lower ISO, and the noise is less. We can see more detail.
Right.
We can see the dark lanes much better.
Exactly.
Yeah.
Wow.
And that's what it's all about. So you're just trying to get the best. You play them off each other. So now, like, if we were to go to the Comet and do this, it might look very different. So why don't we?
Hey, let's do it. Hang on, everybody. Buckle up. Here we go.
Here we're going to go back to the Comet now. All right, and I have the coordinates in, so we're just going to hit go to because I left those coordinates in. And now, zoom, away we go. And you'll see star streaks as we end up going through, and then it's going to go to another star to act as the guide location to take it down. And if we don't miss my guess, it's going to take us to where are we going? We're going to be going, depends on the time, it might take us to a different location. Okay, yeah. Now it's taking us down to one of the stars in the constellation Orion, this one. Okay, Menkaurian. And then it's going to zip up and take us to the Comet location after it centers that. The dome's in the way a little bit here, so hopefully it doesn't interfere. When the roll-off roof's in place, that's not going to happen.
Yeah.
Okay, so at least it got to where it's going to go. So now it's going to come over to the Comet location. This is where it's going now. Alrighty. And by now you should recognize these stars.
Yeah.
I would say. Yeah. So again, like I said, the two end stars of the Big Dipper. This is the Big Dipper right here. Okay, right there's the ladle of the Dipper, and there's the tail. Okay, the Big Dipper, all part of the greater constellation of the Great Bear, Ursa Major. Okay, but those two stars point to the North Star, and you go away from both of those constellations about halfway through. You go about halfway and go the length of the Big Dipper's ladle and tail, and that takes you to the Comet location. Now, let's do the same thing, 3,225 seconds here, and see if this combination is good for the Comet as well. It may not be. If the Comet's much fainter, it probably won't be. And
what would cause the comet to be? I just have to interrupt here.
No, go ahead.
What would cause the comet to be fainter?
Well, as the comet ends up evaporating, a lot of that material that is bright now is going to be less bright. You know?
Because there's simply less of it.
Yeah.
Okay.
Yeah.
Okay.
Okay, so we can see here. There's the comet there, and I'm going to just come back to my one here, and I gotta take. I'm talking to myself, not a problem. I always do that.
You're talking to all of us. We're all listening. We're cued in.
Yeah, but I'm just trying to catch now. I think. Okay, so this is actually straightforward now. So what I can do is to bring the comet down into, to bring the comet down into where we want to go. All I have to do now is to drop it down. So let's bring it down. Okay, you can see the stars moving as I drop it down. And then move it over a little bit. And the comet should be right about here. So here we go. Let's just do 25 seconds at 3200 now. Here. And see if the comet is back. I was looking at these two stars and these two here. So we should see this now come back. This is the previous photo we took, and we should see, should be right about here. I'll put the cursor where I think it's going to be.
Okay.
Let's see if I'm close.
I see something sort of.
You got to just rotate it first.
Mm.
Yep. And then I'd be...
Yeah. There's that blur right there. Yep.
Yeah, and there it is. And so we're actually seeing the comet.
There it is.
Yeah. And see, the comet could benefit. See, this comet, because of its faintness, could benefit from a longer setting. And I'm going to do 1 minute at 3200. Why? Because I want to torture all of you. No, I don't.
Why? Because we like you.
Yes. M-I-C-K-E-Y.
Yeah, exactly. Thank you. Yep. Mickey Mouse Club. Right. Exactly. Wow. Okay, there it is.
Axie is asking, what are lanes? In the galaxy, sometimes we see these dark areas of dust, as we pointed out. And what they are is actual dust. Much of the dust is created in older stars like red giants. As they get bigger and bigger and bigger and they expand, they will create dust in their outer atmospheres. And what is dust? Dust is the accumulation of debris and material that makes its way to the surface. Larger and larger molecules form, and they end up being something that ends up in the outer atmosphere, and this is something that we look at as a solid material. We would see it as a solid material, but because it's usually dark, and not lit up by anything, we see this dark material, and we call those dark lanes in the galaxy. Now, in the case where that dark material is lit up by something, then we will see something like this. Okay?
Wow.
This is dark material that I'm talking about. So this material in a galaxy is a dark lane material. Okay, this dark dust right here. See the black?
And Mark, I just have to, here's another ignorant question. How do we differentiate that from what is termed debris?
Well, there is none. It's all debris. It's the remnant of nuclear fires in the hearts of the stars. And here, this is the Orion Nebula again, and here you can see this tongue of dark dust that is silhouetted by the much brighter nebula way behind it. Okay, so this is reaching over the front of the nebula, basically, as it is over the front of this. This is all dark nebula in here. In fact, all of this area around here is all dark nebula. And where these hot stars are, this dark dust also has gas in it, hydrogen gas and oxygen, made in stars. And so at this location, where this was a dark nebula at one point, these stars winked on at some point, and they started ionizing the hydrogen gas and the oxygen atoms, and this started causing these atoms to glow. And that's why we see this area that used to be dark like this is now lit, like a little blister sticking out of the dark, dusty area. And actually, this is called the Orion molecular cloud. Okay, this is really where this is. So, as an example, so when we look back at our image of the comet, okay, we don't see anything dark for the comet because the comet is basically giving off tiny particles, but the dust that it's giving off and leaving a tail behind is a small amount a small amount of an overall large amount that would occurs over a long period of time with many, many billions of comets over billions of years. And so that dust could indeed contribute to being a dark lane in a galaxy somewhere. Our galaxy here, in fact.
I see. Wow.
See, so a lot of this is these things are all related in a sense.
It's extraordinary to contemplate. I mean, we here on Earth in our, tectonic plates, blah, 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 weather situations. I mean, it's also traceable and so much in real time. And to think that this is out there and these things are, wow. All I can say is wow.
Well, the universe, it throws curveballs at us. I mean, on SkyTour Radio, which is our show that Amanda Kern's my co-host and Daryl Mason's on. SkyTour Radio is a fixture on KGRA Radio now, kgraradio.com, on Sundays from 8 to 10 p.m. I almost said 8 to 12. My God. 8 to 10 p.m. on Sunday nights on kgraradio.com. And we actually do pretty well. We're like number 3 to 4 in our time slot. And
very good. Yes, that's a TalkStream Live ratings. Yep.
Yeah.
Real time. Yep.
And then, for those of you that might recognize Carol's voice, Carol is the voice of Behind the Obsidian Curtain. And Behind the Obsidian Curtain is on Fridays at 7 p.m. on kgraradio.com.
Oh, bless your heart. Thank you so much. Yep,
oh,
indeed.
You
and we also get pretty good ratings, which, floors me. But yeah, okay.
Yeah.
So here we all are. Mm-hmm.
And I see Amanda is here.
Oh my God. Hello, Amanda. Oh my God. So good to see you. And her phone has been found.
I know.
Long story. Yep, indeed.
Amanda,
wow.
If you'd like to join us, I'd be happy to add you to the call. Just let me know. Happy to join if you like.
Like Daryl's tagline is everything's better with Amanda. And, I wholeheartedly concur.
Yeah. So we'll wait for her to see if she's interested in coming on.
Okay.
It'd be kind of fun to have her around.
Exactly.
Yeah. So anyway, the comet tonight is looking pretty cool,
It is.
I'm liking how the this former nucleus is now extended out. Okay. So I think that's something that is really part and parcel to what goes on with comets. And
tracking the way you would normally assume a comet to track.
Yeah, exactly.
Hello.
And
oh my God, Amanda, there you are.
Ladies
Hello, my dear.
Ladies and gentlemen of SkyTour LiveStream, this is Amanda Curran, my typical co-host for SkyTour LiveStream and my co-host for SkyTour Radio, all things SkyTour with Amanda. Hi, Amanda.
Hi, Mark. How are you?
I'm fine. Thank you for coming along. Thanks for joining us.
Well, I had no idea. It was a pretty late message for a start time. I was upstairs trying to sleep, and I tossed and turned for about 3 hours, and I said, screw it, I'm getting up.
Hey, you know what?
And then I saw you were streaming, and I was like, hey.
Yeah.
Well, you felt our vibrations, Amanda. That's all. How else can I explain that? Yeah.
Well,
how are you?
Yeah, tell us.
I'm all right. Tired, but I'm all right. How are you guys doing?
Oh, very good.
Well.
It was torrential rain all here today, and we have a ravine here next to the house. The ravine looked like a raging torrent. Usually it's dry, and it was a raging torrent today. My retaining wall at the back of the property had water streams coming through it. I thought it was going to go down. And the sky was just dark and rainy all day long, and I didn't think that this would ever occur tonight. I thought, well, certainly not going to stream tonight. Yeah, and then it was around 4:30, 5 o'clock, and I noticed that it stopped raining. I went outside, and I was astonished. I was like, was I in a time warp or something? Did a week go by? It's like totally clear, not a cloud in the sky, and it's it's like 60 degrees, you know? Really, really nice.
That is so strange. Yeah. I know. I looked at the the little weather thing on my phone in terms of what weather was like in your area, and I thought, well, there's no way there would ever be a live stream tonight. But then here we are. So yeah. Wow.
And that's why it's so important to hit that bell by the subscribe button. Subscribing's great. You'll definitely be able to catch our videos, but if you hit the bell, then you'll be notified right away when we go live, because this can happen all the time. Like, we might plan on a stream and then clouds show up out of nowhere, and obviously, because of tonight, the opposite can happen. So
yeah, that's true.
Absolutely. Yes, indeed. So, oh my gosh, so good to hear your voice, my dear.
Thank you.
Yeah, and we're doing a 1 minute shot here, which is just about done. And it's going to be of the comet again, but it's make it a little brighter and maybe more colorful. Trying to get that cyanide color because everyone wants to see that beautiful green.
Amanda, teal, green, blue. Yes, indeed.
Yeah, there we got it.
Oh my God, there we go.
Why did I think cyanide was red?
That's funny. I don't know.
I don't know. I mean,
There's a hymn song called "Underneath the Cyanide Sky." It always gave me the impression that it was a red sky.
Oh.
I'll be darned. What band was that again?
Him.
Ah, you're such a musicologist. You beat me to the punch, indeed.
They're from Finland, actually, so not many people may have heard of them.
I certainly don't. But she's up in Nova Scotia, which is closer to Finland. Nova Scotia is closer to Finland, right? By a little bit, anyway, compared to me.
Right. Oh.
Yeah.
It's a good album title, Closer to Finland, right?
That's right.
But yeah. Well, so we're seeing it now. There it is.
Yeah, and what I want to do is I want to see if we can. This wasn't. Oh, it's up there. I wanted to get a photo of it when it was earlier, and you can actually see where it was. It was actually, it had passed this star, remember?
Yes, right.
It was here, and it's gone, like I said, it's gone down like this. Oh, look at, we can clearly see this, guys. Do you see the multiple objects now?
Yeah, and what's that red over to the left?
That red over to the left is just noise.
Okay.
You can see it here too. This is noise from the camera chip. But we are doing this in white light, remember?
Right.
But what I'd like to do is to take another photo and do this photo in a different wavelength. I want to take this and go... I want to go to the one of the narrowband filters. This one. And we're gonna probably have to refocus. We have to refocus, but I'm gonna do this now. And I gotta apologize. I don't know how Christmas music got mixed into the ambient. I have no idea.
Well, again, it's sort of like, I don't know, some sort of positive thing that we will have Christmas. Okay. I don't know.
Okay, well then that's a good thing to say.
Yeah.
Yeah.
I just saw a meme the other day. It said, I can't remember the three things it was. Halloween this year is on a full moon. It's on a Saturday. And something else. And daylight savings time goes back, so we get an extra hour that night. So people are saying, like, we had better be at a quarantine by Halloween, or people are gonna have fits. So
yeah, exactly. Masks take on a whole new meaning.
Yeah.
Exactly.
Yeah. Everybody will go out as a surgeon.
Yeah. Oh my God. Yep.
Yeah. Yeah, I'm a surgeon. I dressed up as a surgeon. Oh, okay. Yeah, that's original.
Yep.
Well, I was honestly thinking that because so many people are making the comparison to superheroes and like healthcare workers, and there's so many memes going around now, like Superman handing a nurse his cape and welcoming doctors to the team of the Justice League and stuff like that. I see so many, and you know what? Hey, you want to go out as a superhero for Halloween? Try doctor or a nurse.
Exactly. Or even like, shall we even, enter into grocery store workers? Because hello. Yep, indeed. Yeah.
Yeah.
I mean, at least, you're more equipped as a healthcare professional, but I mean, you're just, a defenseless little pawn over in the grocery store. Like, I don't know what I would do. I mean, people must be crying going into work every day. There's going to be so many mental health issues after this.
You think so?
That's another thing. I have a colleague from back in high school who's become she's a psychologist, et cetera, who has moved to, of course, online stuff. And she said that it was kind of a shaky situation for some of her clients, but now everybody is sort of signed on and used to this. But I mean, that's the deal, is like, even if you were like okay before and coping with whatever your inadequacies were, your uncomforts, with your life as you knew it, I mean, it's got to be exacerbated. And that's a kind of so like, here's the deal, is that, Mark, you are allowing us to look up, look back, look forward, look into the cosmos, which will not change, as there is no impact to the cosmos from this at all.
That's right.
And it puts everything in perspective.
That's right. There won't be any. The cosmos could care less what's going on.
Right.
On, as Carl Sagan says, the pale blue dot, which is our planet.
Yep.
All right. That I was refocusing, so I'm going to do 1 minute at 4,000. Let's try that. Actually, that didn't work too well. We got to go up more. I'm glad I thought of that. There we go. We're going to go 10,000 actually. All right, so now we'll do that, and we'll come back to here. And this is sort of a bad photo. It's a little blurred. But our white light photo earlier is kind of cool. And the more time between shots of the comet, we can actually see... Whoops, sorry. When there's more shots of the comet in between, when there's more time in between, we can see movement easier. So you'll see like this star with the cometary nucleus here. But this nucleus, like I said, we can actually, if we had the right tools, we could just do a density study of the comet here, and we could figure out what parts of the comet are denser, and that is to say, brighter, and then we could figure out potentially how many pieces there are to this comet right now. Like I said, comets should be round balls, like a star with a tail on it. Okay, this one, it's indistinct and it's gone to a long dash, and that usually means that it's been something that has been broken apart. It's way over there. I didn't bring it over enough. I'm sorry. I got the focus right, but I gotta bring it over. Oh yeah. So what can I say?
Well, you're only human.
Are you sure?
Well, I don't know, but from what my assessment is, like, I don't know. And is it a good thing or a bad thing? Well,
I didn't know
the
it was
votes
human.
are votes are coming in. I was just kind of, ask you to reiterate, when we see that there is a part of that is blue, and a part that the comet, a part that's blue and a part that's red, and the delineation is
the part that's, say that again, I'm sorry.
I don't know. I don't know. This may be like, Amanda, help me. But I mean, this may be like a question based on my scientific ignorance.
No. But ask it one more time, because I was actually focusing on getting the comet back into the frame
as we
here.
look at the comet, there appears to be in my field of view, on my let's see, and we will. I think you're bringing it up now. Okay. And now I'm over to the left, and so now your cursor is okay. There seems to be circling there seems to be toward the right a little bit more blue than toward the left, which is a little bit more green. And does that tell us something?
Absolutely, Carol.
Okay.
Yeah, that's actually very prescient of you.
Why, thank you, sir.
Yeah, and I'm going to tell you about that right in a few seconds once I get this to show up. That's from the earlier shot. Let's drop that out. Okay, when we look at a comet, and I gotta wait for this next one to come in, because when it comes in, we'll have a better, maybe like this is a bad photo, but hey, it'll be good in a minute. This next one will be good. This is gonna be more here, so it'll be right about here. I'll put my cursor right where I think it's gonna be. I think that's maybe even here. All right, and when you notice that the comet has a bluer color in some locations than the other, that is not an invalid observation, because it does have a blue tail, as well as the green coma, and then the dust tail, which typically will just reflect the light of the sun. So the dust tail might be kind of whitish, and the coma might be the green carbon ionized compounds that end up glowing green. And then you'll have this blue tail, which is the result of the solar wind, which is, high energy protons and electrons.
Right.
And that is going to interact with the carbon molecules, the carbon compounds on the comet. Again, the carbon, C2, carbon monoxide, CO, carbon or cyanogen, carbon and nitrogen. And that's the kind of thing that would actually be giving off the greenish light. Okay?
Mm-hmm.
So that's the green light parts. But I apparently did not hit the start button on that. Lucky me.
Oops.
That's okay. That's fine.
Okay.
But anyway, but the blue indicates the ion tail. That's the interacting electrically active atoms that have been strewn in the anti-direction of the sun. So it's going away from the sun at all times. And that tail always points away from the sun, the ion tail. All right. And as the comet goes around the sun, that ion tail swings around. And when the comet's going away from the sun, it's heading into the ion tail, because the ion tail's facing away from the sun. So then the comet's going in the same direction, and it's heading into the tail. But the dust tail is always being dragged behind the path of the comet. So as it goes around the sun, the tails are always going in different directions, and apparently, when you look at it. Okay, so
Right.
And this is a better one now to show you. So let's take a look. So when you look at this, it's really hard to see it now because this comet has broken up so badly, I think. But so there is the ion tail that we had was right here. We saw the ion tail last time, but there's a haze here, which is probably the dust tail, and part of the dust tail, and it's going to be stretching behind the comet as well. So it has a couple of tails, but it's just not that obvious, is it?
Right, they're very subtle.
They are very subtle, and that has to do with a couple things. With the it has to do with the fact that this comet is getting much fainter, and also has to do with the fact that the comet is also breaking apart, and we're losing a lot of that beautiful delineation there.
Right.
Yeah. Amanda, you still with us?
I am. Someone's saying there might be some echoing going on.
Oh.
I didn't hear any when I first joined, and it's the first time I'm seeing it, so I'm not sure what's going on.
Like a auditory or visual echoing?
Auditory.
Oops. Okay.
Yeah, I do not know.
I'm not hearing
If anyone
anything.
else is hearing it, let me know. I didn't hear it when I first got into the room, but
Yeah.
I mean, if it's like echoing from the music or something, I might not have noticed.
Good point.
Well, Carol, you don't have your speakers.
Nope, everything's shut down.
Okay.
Yep.
Because sometimes that's really a silly thing that happens sometimes, is your speakers are left on. I've done it. It's like, what? It's echoing. Why is it echoing? Oh, I did it.
Right.
My fault.
No. I'm my laptop is shut down,
Okay.
and I'm on my main work computer, and yeah. And so we didn't. I'm thinking if it was me, we would have experienced that from the get-go, but
Yeah, right.
I don't think that's the case. Yeah.
So here you can see this beautiful blue-green, and the filter is adding a little bit of the blue as well. It's sort of shifting it toward the blue, but this is really the green coma of the comet. And the ion tail is less distinct. In fact, we saw it very clearly in the early days of the comet, and now it's actually fading fast.
Yeah.
Okay, sorry, I gotta...
We also have a kind of a question request, and I don't think it's possible at the moment, but might be something to consider in the future.
Okay.
If any of our viewers, listeners wanted to join the conversation. I don't know if that's going to be possible in the future, but
I don't see why not. I've had other people come on. It's like we can turn the SkyTour LiveStream into a call-in type show. But it'd have to be
there's
Skype.
a few people that are dying to come on and ask questions and whatnot. So
Oh, that would be cool.
Really, like who?
like Lynch Gaming, actually. Lynch is the one that told us they were going to astronomy school.
Yes, Kyle. I think Kyle Lynch is the guy we're referring to. Yeah, indeed. As of last night. Yeah.
Oh, all right. Well, that's pretty cool. Well, you know what? That is something that we can plan on and do. Is it Kyle, actually?
I think so. Kyle will tell us.
I'm not sure. What do you want to give your name, Lynch?
I think he had kind of identified himself last night, if I'm correct, as Kyle Lynch Gaming. Yep. Astrology student, etc., etc. Hello.
Astronomy, not
Hi,
astrology.
Yep. He says, "Yep, that's me." Okay, so, I guess that's the dude. You bet.
All right.
Yes.
I want to answer Trisha's question too. She said, "Will the comet burn up or keep going indefinitely?"
Good question.
Kind of relates to what Charles Smar had said earlier, I believe. This particular comet has a 6,016-year orbit. So what we're seeing on the screen now is the carbon outgassing, this glow of the carbon compounds that have been trapped in that comet's surface for 4.6 billion years from the very beginning of the solar system. And so this is their big show. This is their last gasp. Now, will the comet survive? Some comets do. They're massive, and and when I say massive, they're actually cohesive and more solid. If a comet is more of a snowball consistency of different kinds of ices, where it doesn't have a lot of rock component in the center, maybe, then it's possible that the comet can break up as we see this one doing. Okay, the comets generally they can be periodic, or they can be on a path that takes them in one time and then they're out forever, like the comet Borisov that just came through. That was an interstellar comet. Came from very, very high above the solar system plane, went through, and will head out of the solar system, never to come back. It's a one-time visitor in the lifetime of the universe, probably.
Wow.
Yeah. And so this particular comet, some will be periodic, but all comets are being evaporated. Each time they come back around the sun, they're being evaporated a little bit more. Everything you see here on the screen shows you that evaporation process happening, and it leaves a dust trail behind it. That's mass that's coming from the comet, You're seeing the carbon atoms up here that are glowing green. Well, those are not going to go back onto the comet. They're gone forever.
Yeah.
So this comet is slowly evaporating, as all comets do. They can be periodic, meaning they come back over and over, but that's only going to last until they eventually will break up. Who knows how many times this comet has already gone around the sun?
Is that due to the Roche limit?
Partially due to not the Roche limit per se, okay, because it doesn't get close enough to the sun. And by the way, Amanda, I want to compliment you on bringing that up, because that shows that you listen to when we talk on SkyTour Radio, and you've gotten so much astronomy background. You just spit these things out, and it's like, wow. In this case,
I love that.
No. I wish. I'm too honest.
No.
I read that in a chat.
Hey, no.
I don't know what a Roche limit is. Come on, guys.
Oh, no.
I'm not even pronouncing it right, apparently. I thought I was so clever. I'm like, oh, that's got to be Roche.
Oh, Amanda, you were too self-effacing.
Okay. Let me explain. The Roche limit is what happens when, if the moon were to get closer to the Earth, okay? A couple things happen. The closer an object gets to another mass like this, the less likely that it can maintain its own revolutions and spin. It'll be tidally locked. The moon is tidally locked, and it's 250,000 miles away. Okay, but if it got closer, there's a certain distance based on the two masses of objects that if it gets too close, then the differential gravitational pull on one side versus the other will tear it apart. And
tear what apart? The moon?
Yeah, the moon, the smaller object that's orbiting another object. Okay.
So that's what I was wondering. This could be applied to any two big objects, and the smaller one would be ripped apart.
Yes, if it gets too close. But the fact that the comet's breaking apart is not because it's inside the Roche limit for the sun, but because the comet itself is not very solid. And it was made more of a snowball-y type material where it's not really compressed to the hardness of rock, It was actually somewhat loose, so it's actually breaking apart because as the sun heats it up, it'll crack. The solid ices will crack and break apart, and so it does evaporate. And in this case, there's a chance that a comet can be fractured, and this one apparently has done so, has fractured. Okay, now I'm gonna do another shot here because we let a few minutes pass. I want to get just a nice little comparison. Okay, so
it's great to see that time thing, the time factor. Very nice.
Yeah. See, even between those two, the comet moved a little bit this way to the right. You can see how it moved a little bit, a little to the left, a little to the right. And I really like the fact that, when people look out at the immutable stars that never seem to move, if we had longer time lifespans, okay, we would know that the universe moves all around us. And if we experienced time differently, then, if we experienced, say, 1,000 years every second, we'd see the universe moving around us slowly, but perceptibly. I guess, I think we have clouds.
Yeah, clouds are a dome issue. It looks...
it's a purpley, so... But you know what? That's okay. I can't... Oh, actually, you know what? Why don't we just go see? We have the ability to look, don't we?
Don't we?
Yeah, there is. Okay, let me show you the telescope view over here. Let me bring us down. Okay, do this. And get us over to here. And now, bring up the cams. As you can see down here, in the blue cam, the telescope is actually pointing right out of the dome. So I think you can hear wind too. So I'm going to start up. I hadn't run it yet today. I didn't even think about that. The all sky cam.
So what's your weather like? What's your weather like in terms of?
Well, it's nice and warm at least. It's 60, which is warm enough for me. And
cool.
Yeah. And so what I'll do is I'll just take a picture here. I knew I had some clouds to the north earlier. But you know what? We'll let this take its picture and then we'll come back to it.
Donald has a question.
Sure.
He wants to know if he's seeing two parts of the comet's head or two stars behind the comet. I think he's just getting here.
No, actually, Donald's been here for a while.
Oh.
Yep. Yeah, Donald.
Sorry, I didn't see you earlier.
Yeah, Donald Kunzer was here
I
before.
got here late myself, so sorry if I missed you saying hi.
Okay.
I'm just trying to.
Yeah, it's timing, Amanda. You bet.
Yeah.
And Daniel Whitaker is correct. Shoemaker Levy did, in fact, break apart because of the fact that Jupiter was a very powerful gravitational ripper. And it tore it apart. And a string of pearls of these beautiful luminescent cometary fragments struck Jupiter over several hours.
Ooh, a string of pearls.
And I actually saw it with my telescope live.
Wow.
Yeah, and I was looking at it from the yard of my house where I used to live, standing out there with a telescope set up on a tripod.
Oh my
and I was
God.
watching Shoemaker Levy strike Jupiter. We couldn't see it because it happened on the dark side of Jupiter, or where we couldn't see it. And then as it rotated into view, we saw it. It was really, really amazing.
Oh, damn.
Oh, yeah.
But
really
as
something.
to what Donald was saying.
Yeah. What did he say? I missed it.
He said he wants to know, is he seeing two parts of the comet's head or two stars behind the comet?
Oh, well, I know that there's actually stars behind the comet as well. Okay. And so, for instance, let me... Okay, so like when we're here, okay, we're seeing some noise as well. And like the comet's here, and you see those two things are noise. But these are stars that are well far beyond the comet. Okay? These two things are stars way beyond the comet. Okay? And then you can see the stars again here. Okay? And unfortunately, I think we had a cloud. I gotta go look and see what we got. Hopefully. Oh, Jesus. This is our view right now. We've got high clouds out there. This moisture has been on.
What is that?
That's water on the hemispherical cover of the camera. That's been there all day. Oh, but this is why it was purpley like that. We actually finally lost our sky because of clouds. This is why you always bring up the all-sky cam before you do anything else. Right. So what we'll do is we're going to have
Sorry,
to...
that's your camera lens?
This is actually the all-sky cam. Have you seen this before? Have you seen the all-sky camera?
Wow.
It's a new addition.
What?
I added it. So this is actually for SkyTour West. And what it is it's a camera that has a 180-degree view, and looks in all directions.
Wow.
Okay, so we actually see... I can get that to stop doing that. Yeah. And we can see this... We can see the view, and then every 45 seconds we get a new image. And I just didn't get the water off it. Normally you don't have to because it will dry during the day and at night, But it was torrential rain here all day today, and finally cleared for a little while. But
it's coming my way.
Oh, is it?
Yeah.
Okay. But this is how we'll be able to, in part, tell the weather when we're doing the Arizona work, because we will be able to, and we're gonna have a weather station too, incidentally. Which is another thing I didn't tell anybody about.
That's
I forgot. We're gonna have an on-site weather station, so we'll be able to know what's coming as well.
Fantastic, because I know earlier today, I like in I don't know around noon, I checked the weather in your area, and I thought, well, there's no way you're going to be doing this tonight. But it wasn't accurate. So.
Yeah, we got something tonight, didn't we?
Yeah, indeed, we did.
We did. We got a little out of it, didn't we?
Absolutely.
Yeah. So what I'm going to do is, I am going to do this, because since we're going to be closing down, obviously, I'm going to bring up and enlarge. I'm going to enlarge this this camera group for you, so you can see what's going on in the dome, and you may even hear it too. Okay.
Do we have time for another question?
Sure. I'm going to park the telescope, though, so I'm going to put the telescope in its parked mode, and you'll see that happen.
I hope we heard that great noise. I love that noise.
I think you will.
I'm just scared if I start with the question, this big grind is going to hit halfway through, so...
I love it, Amanda. That's hilarious.
And watch, you won't hear a peep.
Right.
Dead air for the next 30 seconds.
Well, the telescope is actually...
Oh, there we go.
There it is.
I was waiting to shut you down, Mark.
Ah.
Well, I'll try it. Rip Blue Jay wants to know, how can you accurately know the size of the nucleus before separation, and how can you determine the size of the fragments? Great question.
It is, and it's an inexact science, Blue Jay, and the reason it's inexact is because we can't get out to the comet. There have been a couple missions to comets. The Rosetta mission, for instance, landed on Churyumov-Gerasimenko, Comet 67P. Right. The Philae lander landed on there and bounced a while and then came to rest in a crevasse. But the Rosetta mission was highly successful, and we got to see this absolutely stunning comet up close and saw what a comet looks like up close. Then there was Giotto, Giotto, and the Japanese are at asteroid Bennu right now and doing a sample return mission. So we're getting out into the outer solar system to actually see these things of which we speak. And I think it's kind of interesting to see that we're now learning so much more. Now, for instance, we get out to an asteroid like Bennu, and it's really a weird shape. It turns out that Bennu is more of a rubble pile held together by mutual gravity rather than a rocky asteroid.
Wow.
We don't know if you stepped on Bennu, if you'd kind of like fall in and fall through the surface a little bit and like, because of the slight little gravity that's there. I mean, the amount of gravity is so small, but it's enough to actually hold the gravel pile together. And there are asteroids that are just gravel piles.
And so a gravel pile, a rubble pile, what are we talking, like a space debris, or what would be the provenance of that rubble?
Well, in the early solar system, when planetary formation was going on, these planets formed and left lots of debris behind. And if some of that debris coalesced into a pile of rubble that was sort of mutually attracted to each other, then maybe it acquired more over time. and that material that it acquired over time could very well end up becoming an asteroid-sized pile of rubble. And we actually see that.
Wow.
We actually see that. Yep. So,
Thank you for that, because wow, that is an education furthering thing there. Wow, thank you.
Oh yeah, of course. I mean, it's fine. Amanda, did I have some questions that I didn't answer?
No, just that one. There's also a comment. Rip Blue Jay wants to know if you're going to be putting on any kind of show as the comet gets closer. I think we're going to try to do this as much as we can until we can't see it anymore, depending on the sky. Correct?
That is correct.
Yeah.
Yeah, we're gonna follow.
Hit subscribe and make sure you hit that bell, because
yeah,
we go by the sky. If it's cloudy, unfortunately, we can't give you a time and day. It's just not realistic. So, hit that bell, and anytime we go live, you will know about it.
Exactly so.
Indeed, notification is everything.
And you know what? I'm going to say this too, guys. This channel has gained almost 80 subscribers in the last couple weeks.
Wow.
I'm seeing some new names here. I don't know if they've been here a lot and just shy, not talking before, or I'm not sure what's changed, but I've noticed a few names. Welcome, everybody.
Yeah, I've been saying that. I mean, we have 42 watching now. We had up to 68 last night.
Fantastic.
And
I'm wondering if, with so many people not working and having more free time, if they're looking for live videos and people knowing about this comet, now that they can stay up later, and they have time to do this, maybe,
Bingo, Amanda. Indeed, absolutely.
Yeah, no, certainly, it's sort of a place to spend some time, right? No doubt. But all right, well, I have to go.
We do another question. I don't know if you wanna...
Yeah, go ahead.
Okay. From Bera, they want to know. Okay, they said the comet is going sideways, and the tail is not against the direction of movement, and there is no friction. So why is the comet disintegrating?
Well, that's the thing. What's going on at the comet is a bunch of things. Let's go down to the surface of the comet, okay? In our minds, if we look at the surface of the comet, all right, what we're going to find is that the surface of the comet has a very tumultuous surface. It's a surface tortured by previous iterations of going around the sun. So there's lumps and there's valleys and there's nodules and melted and refrozen areas on this comet. Inside of all that material, which is made up of many different kinds of ices, okay, there is trapped gases as well. And when the sun starts hitting those gases for the first time in many thousands of years, then the surface heats up, and that causes things to happen like gas jets, like burst through the surface, because now the pressure's building as the sun hits the surface of the comet for the first time, and years and years and years, decades, millennia. Then under the subsurface composition made with these gas pockets that are now trapped, frozen, are under a lot of pressure now as they expand, and they burst through the surface and make these jets. These bursts through the surface also contribute to the basically the earthquakes, effectively the comet quakes that are occurring on the comet, and they can fracture the comet if there's enough of them. And this particular comet was possibly just a slush ball that had frozen, and when the sun started warming it up, now it was just like a loose snowball, and it didn't take much for this comet to become less than one cohesive piece and break apart. So the heat of the sun warming up the surface would cause it to break apart like that, and for the reason I mentioned, because there would be this gas that's trapped below surface that would burst through the surface. With the Rosetta mission, we saw on Churyumov-Gerasimenko, that comet, we actually saw these jets shooting out, and you could see them coming out on the comet. And it's really astonishing to actually see it. And the comet looks really kind of like an alien world. It looks like a melted candy mixed with ash. It's really weird. And the other thing too, which is kind of odd, and it's going to sound weird to you guys because this is something we found. The comet's surfaces are actually very dark, almost black. Okay, and I know that's odd, but the comet's surfaces are actually nearly black because of the radiation over the years, the molecular compounds in particular. So it's really just a strange chemical composition that we see, on the surface of a comet.
Fair is pressing it, saying the comet was orbiting these conditions for thousands of years. So now why? Why now? Is that because it hadn't been that close to the sun as it was breaking apart, so it couldn't have those chemical reactions?
No, it's just that there's so many comets, billions of comets, that it's not unlikely that a comet will disintegrate when we see it. So I don't think that's I don't think that's actually it's not very surprising that it's happening now. It's actually kind of cool that we see it now.
Maybe it's just because we can see it. Yeah, maybe it happens all the time. It's just so far out we have no idea.
Yeah, I mean, and we don't know. Some comets circle the sun, and they may break up. We've seen this before. Other comets have broken up. I know that other comets have actually very dramatically broken up, not just because they hit Jupiter like Shoemaker-Levy 9, but other comets have as they've gone around the sun. It's a very high-stress time for a comet as it goes around the sun. As it gets closer to the sun and starts to go around the sun, it's actually going to be a very, very, very high gravitational field. The comet's moving very fast. So it's going to really stress the comet's surface. And if it's ever going to break up, that's the place it'll break up. And if a comet's big enough, it might be able to hold its cohesion together. And it might be cohesive, but in general, it's not a very cohesive object because it really is made of a bunch of ices that have a lot of trapped gases in them. So they do evaporate as they go around the sun each time they appear. So that's that's how it works with comets. But hey, like I said, we'll be back again the next clear night. This was a gimme. This was a great night to actually have some time. The telescope here. This is the face of the telescope. You see that round object there? That's actually another mirror. That's at the other side of it. Here is the mirror, and wow. This is a plate here, a disc of glass. And light goes in, hits a primary mirror down here, bounces up to this second mirror, and then goes out through a hole in the bottom of the mirror to the filter wheel, which is here on the telescope, all right, and then the camera, which is attached to that filter wheel. So that's actually what we're looking at there, and I can actually kind of lower it and show you what I'm talking about.
Fantastic.
Yeah. So if we zoom in a little, okay, you can see now there's that glass plate.
Right.
Okay. Then the light goes down here, hits a big mirror down here, reflects up here, hits the center of this mirror, and then gets directed down through here. This is the business end down here. This is where there's a piece of instrumentation here, there's a filter wheel here, and there's a camera on the back end here that captures it all. Okay, so that's actually what we're seeing here.
Yeah, like from my grandparents' time. Oh, the music goes in and here, it circles around, blah blah, and it comes out here. Oh my. Okay, right. I'm sketchy on that, but yeah, wow. And who'd have thunk it? This is just so extraordinary, and to be able to see the process, and to have you translate what we're looking at.
Yeah, no, it's a wonderful
Unparalleled.
It's a wonderful. Well, first of all, it's a lot of fun having a real observatory.
Yeah.
Okay, there's no doubt about it. All right, but you also have to keep in mind that a lot of work went into making this observatory here. And a lot more work is going into making the Arizona Observatory.
Yeah.
This telescope is the exact instrument that's going into the Arizona Observatory. I've got it set up in here on a test basis, and behind me on a table is the other one that was in there that it's being refurbished and rehabbed in here. And I'm probably going to sell it and get another one of these to put back in here, because I want to have two identical instruments for the Arizona Observatory and the East Coast Observatory. And then this building, the dome, is going to have to go away, and I'm going to trade this for a roll-off roof observatory like we're building in Arizona, because the roll-off roof is very important. That is essential and crucial.
Right, because that can be, am I correct, that can be remote controlled?
Yeah, the roof can be remote controlled. So, I mean, the dome can be remote controlled too.
Mm-hmm.
But there's too many problems with that, because at an angle, when you're looking at certain angles, there's more than one telescope on this telescope right now, and you can't see it. And there's a guide telescope that's on here, which is on the other side. You can't see it. And on top of that one, there's yet another tiny one, which is doing a wider view. And, those all have to see the sky.
Right.
And there's points where the dome will be where that tiniest one on the top can't see, but the bigger one can, and the biggest one can. And you just don't know. So the more I look at it, as this here, this telescope's going to have to, it's going to go to Arizona, but if I put another one in like this dome has to be replaced with a roll-off roof observatory. And then I will control
Lynch
it. Yeah, go ahead.
I was just going to say, Lynch wants to know how much that might be. Something like that. That's the kind of telescope he wants.
This telescope here is... No, I don't mind, because this astronomy's for everybody. This is a telescope you work up to, there's no doubt. Okay? But when you work up to this telescope, you're going to spend just about $5,000. Okay? But keep in mind that just some of the filters that I'm using with this telescope are $1,000 a piece. So we're talking about a lot. Now, the benefit is that this is for the Arizona Observatory, so all the best equipment is going to Arizona, and I'm going to backfill with better equipment as we move forward. But we're going to be using Arizona's observatory sky for quite a while, and then we'll do 3D pictures of the moon, things like that. I can't wait to do that.
Katie wants to know, how do we know how visible the comet will be when it's at its closest approach to Earth?
Well, we don't know, because the comet is actually disintegrating. So if it stays kind of like it is, well, then the comet's going to go 20 million miles closer, basically, than it is now. And that should make it a fairly bright object. It could still surprise us and become one of the best comets of the century. But because it's breaking apart, or apparently breaking apart, that's something that is going to make a huge dent in whether it's going to be really visible or not. We don't really know. Hopefully it'll remain cohesive enough and have enough of a coma and enough of a tail that it'll become a really beautiful night sky object. But right now it's 93 million miles away. It's the distance of the sun away, and heading toward the sun. It'll reach the sun on May 31st.
Pardon?
It'll reach the sun May 31st, and it'll reach us May 23rd.
Okay, I was gonna ask, that was my next question, when it would be at its closest. Trish threw out the 23rd, so.
Okay, the 23rd it'll be the closest to the Earth, right? And then
but that's not what's causing the meteor shower that's happening on the 21st.
No.
Is that
No,
Venus?
this comet is not going to be causing any meteor showers for us. Ever. It will never actually cause meteor showers, because this comet is actually, and I said it before, and I'll kind of make a note of it again here. I'll show you. If we just drop in and check out the comet one more time. Let's see.
Even if it disintegrates, I know we talked about this before, but I just want to hear it again. Even if it disintegrates, it wouldn't fall to Earth and create any kind of...
No, because here's the orbit of it. Okay, if you notice, we are looking at this blue ring as the Earth. This is the Earth's orbit right here. Okay. And now if I move this around, you can see that the comet is above and below our orbit. And it never really gets near us. We don't ever get any particles from this comet that are going to hit us. Usually when a comet goes through, if it goes through an area where the Earth has gone through, or the particles drift toward the Earth, then maybe we could actually end up going through the tail of the comet. But this one, it's almost effectively at 90 degrees. It's almost up and down. Not really. It's like at 45. So it doesn't have a whole lot of cometary debris that we're going to be going through. I mean, we're talking about millions of miles separating the either side, and we're never going to see any of that, I don't think.
Another question. I have a guess on the answer, but I'm not sure. Okay. When the comet passes in front of the sun, it's going to the middle between the sun and Earth. So is there a chance the sun's gravity could suck it in or blow it up and block the sun from us? The comet's too small to do that, is it?
Yeah, the comets have hit the sun many, many times in the past, and the sun doesn't even say what happened. The sun just keeps going like nothing happened. Because to an object the size of the sun, a minuscule little 2 or 3 or 4 kilometer size chunk of a comet, it doesn't have any influence on it whatsoever.
And Humpty wants to hear again whereabouts in Arizona you're going to be setting up. It was out in the desert somewhere.
Yeah, we're going to be west of Phoenix by about 65 miles out in the Sonoran Desert. We poured the concrete pad a couple months ago, and the end of June we're going to go out there. We already bought the building. It's a prefabricated building. It's going to be built out there on like June 23rd or 24th. And hopefully before I leave at the end of June out there to come back, we'll be able to have installed all the garage mechanisms to actually roll the roof off as well. And if we have the opener system installed, which is an ambitious ask, then I can actually control it and move that on and off. And then the next trip out will be to bring out this telescope and put this beautiful telescope in that dome. I can't wait to do that. That's going to be good. And then now you see the cover is not on the telescope. That's something you put on manually and take off manually. Well, I developed a system that's going to actually do that automatically, because this is the base of the telescope, and we're going to have an arm that's going to come up using what's called a stepper motor. I'm going to use this motor to kind of open up the telescope at night and close the telescope at night after we're done. So
that will be amazing.
Yeah, it'll just be an automatic system. Yeah. And
what a boon.
Yeah, and there will be a few things that can't happen. For instance, when the telescope is in very windy conditions, then you will not be able to open the dome. Even if you tried, it won't open because it's not going to allow it. that
like a
tells
safety lockdown.
Yeah,
right?
it's going to first query the weather station and see if the winds are less than 14 miles an hour. If they are,
Right.
we'll open that roof. If they're not, then the roof won't open. And I might sit there going, hey, what's wrong? It's broken. Okay, and then I'll have to think to look at the weather station. The weather's going to report too windy.
Yeah.
Or on the very off chance it's going to have bad weather, if rain's in the forecast, because it even rains in the desert, then the dome, the building will not be allowed to open. It'll be an automatically shut down, automatic lockdown. There'll be lockdown for rain, lockdown for wind, lockdown for, most importantly, sandstorms.
Yeah.
The desert gets what are called haboobs.
Right, haboobs, right. And oh my gosh, there's been some stuff on YouTube about those.
Yeah, I was in one.
They're gigantic. Oh,
they are.
really?
Yeah,
Wow.
I was in a 737 coming in for a landing in Phoenix.
Whoa.
And I was looking ahead of the plane by kind of looking through the window to the left. And I was at a window seat. And I was looking far forward as I could to the plane. And I saw this wall of brown. It had to be thousands of feet. We were at like 4,000 feet at that point, and it was thousands of feet above us. And it was looked like a boiling shockwave of brown clouds that were really fairly sharply defined. Like a vertical wall of clouds. It almost reminded me of a hurricane eye wall. Mm-hmm. And it was boiling toward us. And I was like, whoa, that I can physically see it moving. And there was a plane next to us, another 737. We're both Southwest flights. And they turned, they were coming right at us. And they turned right next to us and were now moving parallel to us. They had us come in together. They usually stagger them, I think, on the runways. And they landed us together on the runway. And then once we got on the runway, the pilot shut down and they towed us to the gate because that stuff was upon us. And you could hear it hitting the planes like not hail, but kind of like a very quiet hailstorm with many, many, many millions more hailstones, So the plane was getting battered by this sand. So you can imagine something like that on a telescope like this. Yeah, and that plate up that top there that we talked about there, that glass plate. That glass plate may be a 1/4 inch thick, and it is, but I can tell you this: it would not survive a sandstorm. So that's why the automatic lid has to be closed, and it has to make sure it is a solid closure. And the building cannot be opened in any kind of bad weather. So the rails that are going to be part of the roll-off system for the roof rolling off are going to have shields on them, like skirts that are going to extend down from the side of the building so that there will be very little way that Haboob could send dirt and dust up there because it'll be like too convoluted for it to actually make it up there.
Right, because that would be like pitting damage that couldn't be, couldn't be undone, right?
Yes. And I don't mind dust settling on things. I mean, dust settling on things is okay. There's going to be a high-end computer in there. Well, that computer is going to have the equivalent of a HEPA filter that's taking care of filtering the air going into it. All these little things have to be taken care of, And I realize we're just staring at the telescope, and I'm sorry. But
No. Hey, listen, that's very cool. It's a cool looking telescope.
Yeah, you're seeing it from kind of like this is the bottom side of it, and that's the mount structure. But anyway, I want to thank you guys for coming out. Been here to watch with us tonight. We got to see the comet. We got to see a cool couple of galaxies. There was more things I wanted to show you, but we didn't get to see it, unfortunately. But hey, the next clear night, we'll be here. We'll be out there, and we will be here for you. We'll be making sure that you have a good time. Because I'll tell you, we love what we do. Don't you, Amanda?
I do. Well, I was just saying, Bara's nice comment. It's like listening to the radio. It's surprisingly calming and amusing, especially because of the information provided. I'm thinking, you know what? It's better than radio because we have a live chat and we can answer questions live.
Yeah,
and,
that's true.
You
that's
know,
true.
it's not a big procedure to try to get a question to the host. You know, like.
Yep.
Oh, Amanda, you said it there very well.
Yep,
And
that's
you
right.
know,
And the chat always helps each other out too. If someone else knows an answer, they'll pop it right in.
Exactly.
I usually try to ask on air anyway, just to see if there's maybe a bit more of an explanation or follow-up questions or whatever. But no, these people they know what they're talking about.
They do.
And also, in this venue there is the provided thing that no question is like too silly, too ignorant to ask. I mean, that's how we learn. And the embrace of questions from people who really don't know astronomy but are very wanting to know. I mean, that's what it's all about. So
and they've heard
thank
me
you.
ask some doozies and get lost on what some people would consider very basic concepts. Sometimes it takes a while for me to wrap my head around an idea, but everyone's really patient, even chat, and I think they kind of like when I have my aha moments. When it's oh, now I get it. It's like, yay.
Exactly. Yes, Miranda. I mean, Amanda, because you're definitely way ahead of me, and so
I don't
like
know about that, but,
no, my
I just
dear,
hope that it encourages the shy people.
Yes,
chat
exactly.
comes out with amazing questions that I'd never even consider.
Exactly.
Sure.
And
I agree with that.
I love this community. I say it all the time, but I love this community.
They're good people.
And I love to see it growing. So welcome to all your newcomers, and tell your friends, share on social media,
Yeah.
the more the merrier. And I love having so many different perspectives. Like, this goes all around the world. You never know who's going to drop by, where they're going to come from, what they can see. Some of their ideas and thoughts behind certain things, and it all comes together and gives you different ways of looking at things. And
That's right.
I love it. And I love being part of it. Thank you, Mark. Thank you for bringing this to us and letting me be part of it. And
Amanda, you earned your place here after after the travesty that you got me involved in years ago. You made up for it. That travesty, by the way, was when Amanda, we met many years earlier and didn't even realize it. You want to tell that story, Amanda, or should it?
Yeah, because I don't listen. Clue me in. I'm I don't know this, so
I'm sure you've heard this story, Carol. You must have heard this story.
Actually, Amanda, I have not, my dear. So spill.
Okay, brace yourself, guys, and please don't hold this story against me. Oh my God, it was the most stressful show I ever worked on. I was sick for weeks trying to pull it off. And, I don't know. Are you sure, Mark?
Go right ahead, Amanda.
Right. Well,
Look,
about a year or two before I actually, really spoke to Mark on air, and got to know him, I was a producer at another, radio station, and I got the guests for the hosts and tried to, group themes together and this and that, and, the guy that owned the station said what he really, really wanted. He knew it was going to be a great show. It was going to have high ratings. Everyone was going to get involved. It was going to be wonderful. He wanted me to set up a debate between scientists or astronomers and flat earthers.
Oh my
And it
God.
was going to be set up in a debate kind of mode. Where we'd have one flat earther against one astronomer, then we'd have a different flat earther against a different astronomer, and then we'd have all four kind of have at it. It was almost like setting up a wrestling match, really. And I was like, how flat earthers? I couldn't beat them off with a stick. It was crazy. As soon as people heard about this, every flat earther out there wanted to be part of the show. He was
Hilarious.
getting the
Well,
astronomer.
more than
he
that-
was getting any intelligent, respectable astronomer to, you know, take one on the chin and sink down to this kind of level, you know?
Sink down.
Oh man, I was
Oh my God.
stressing.
And
But I found a really nice guy that really wanted to help, and you know, not that he really wanted to be part of it, but thought, you know, oh, this is going to be a cakewalk, you know, whatever. And his name was Mark D'Antonio.
Oh my God.
and I was on my way to Los
Do we have
Angeles.
a year for that?
I was on my way to Los Angeles because I had to do a talk at a conference, and when I was on my way out there, I forgot that I also was going to have a very tight schedule when I arrived because I had to quickly get into a room or wherever I could actually call in and get on the air. So I had to do this interview as soon as I arrived.
Oh, wow.
No sooner did I get to the hotel when I meet up with Lee Spiegel,
Right.
and I meet up with a number of other people, okay, and we end up in a hospitality suite, and then I tell them, I say, I have to go do a flat Earth thing, and they're looking at me funny, okay, and I was
I
like,
cringed just hearing this part.
Oh my God. Yeah. It's a winsome moment. Yes.
yeah, and I know that I know that it really gets people, but the fact of the matter is, I wasn't prepared to do this interview because I wasn't prepared for the vitriolic anger
Wow.
with which these flat earthers like to spew. I wasn't prepared for that. And so what they do is they basically, they don't just have a discussion. They belittle you. They belittle your science. And I responded more to the belittling comments than I did to trying to form a cogent argument in science. And so, and I've said this publicly, so they won that round because
Wow.
I allowed them to get me flustered because I didn't I didn't look at it from a particular view of science. I actually looked at it from the fact that these guys were just nutcases. And I just went with that like that. And so that ended up being a big problem. And so I ended up not being able to win the argument. In fact, I halfway in, I hung up and just got sick of it,
Wow.
because I thought they were just such idiots, And, one of the guys that was arguing with me, he had in front of him, his pages with arguments all on it. And I'm walking into a hotel after a 6-hour flight, So I wasn't ready. I wasn't prepared. I didn't know what the format exactly was going to be. And I did feel like, this stupid woman who set me up for this ambushed me. And she got me like ambushed by these idiots.
I think I got a nasty message after the show from you too.
You did, because I did not like being ambushed like that, because that was like...
But it wasn't an ambush. You forgot and you weren't prepared.
Yes, that's correct.
In my defense. Thank you.
No. Understand that I've long since stated that many times. I'm not afraid to say when I don't do something right. And if I don't know something, I'll make sure people know.
And for the record, I hate it. I hated trying to ask people, would you come on and argue against these fools? Because everyone was like, I don't have that kind of life to waste, and you took pity on me and you were so kind, and then it turned out so poorly and you were so upset. I felt so bad. It was like, I got you the guest. I don't want to be part of the show anymore, and I felt so bad. And then I guess life goes on and whatever. And then probably about 2 years later, our mutual friend Bill Skywatcher, he had some people on. He added me onto the call, and Keith was there from P&K Space Imaging,
Yep.
and I want to say maybe Eric was on. He's the Massachusetts MUFON director.
Yeah.
And this other guy, who I didn't know. They apparently knew who he was, and they were talking UFOs nonstop, blah blah blah. And I was watching chat, and I was having a little conversation in there, and then this new guy says, "Well, I am actually an astronomer," and it just caught my ear, and I'm like, "Wait, what? Then why are we talking about astronomy? Or why are we talking about UFOs? Why aren't we talking about astronomy? And then I just started asking questions, and I looked him up on Facebook and added him on Skype and stuff, and I'm like, oh, this is awesome, And then a few times later, he mentions this story. Like, he's talking about interviews he's done in the past, and he mentions a story about being conned into a flat Earth debate. And I'm like,
and Amanda's sinking.
Before I said anything to anyone, I said, Bill, this sounds like my story. This sounds like what I did. Could he be talking about me? Am I the show that he's so furious about? And Bill's like, no way. What are the chances? No way. And then I think I finally the more I got to talk to Mark, I was like, you know what? I have a feeling. And I started asking him questions. I'm like, oh my God, yes, he is the one. I went back to my emails. I'm like, here's your email address, dude. Yeah, it was. But
you can see
what, 2-3 years later?
You can see how it turned out.
It's going to be 3 years in June, is it?
Yeah, it's going to turn out.
SkyTour LiveStream.
Yeah, I mean, think about this. Okay, I went from wanting to just, really berate this dumb woman who tried to con me into this. That was the beginning thoughts, remember? Okay. To being someone who said, well, it wasn't really her fault. I think she didn't really know how it was going to go either. And I think that this was actually the fault of the people that were the guests on the other side, the people that were trying to be the flat earthers. They were the ones who conned everybody, including Amanda, including the host of the radio show. In fact, the host of the radio show loved it, I'm sure, because it was all controversy.
Oh, my God.
But
they couldn't have been happier. And the guy that owned the station, they were just jumping for joy. They just sat back and let you guys at it, and yeah. I mean, honestly, we had more people tune in that night and actually come into the chat to, ask questions and make comments, and yeah.
Well, see, I was sitting, I had Lee Spiegel on my left, I had Nick Pope sitting right next to me on the right, because, we're all friends. And, Nick Pope, he was a former Minister of Defense for in the UK. And he was sitting there, and we, as I'm talking on the radio, they're all making these little snide comments in the background that they want me to say, little real nasty quips at the flat earthers, because none of them could, take their baloney. And Nick Pope said something which I did say on the air. He says, Mark, this was at a commercial. He goes, Mark, do this. Tell them there's a spot on the Earth where you can go, and the Earth is flat. You can see the Earth is flat from there. And I said, what do you mean, Nick? Where's that? He goes, it's at a place in Russia called Lake Urey. Lake Urey? Yes. And you say it's Lake Urey. And when they say Urey, you say, yes, you're a nut. Get it? Yes, you're a nut. You're a nut. That was Nick Pope's joke.
Are you going to groan, or shall I?
Well, that was Nick Pope's joke, not mine.
I hate the joke.
Yeah.
Sorry, Nick.
That's okay. He's fine.
But, yeah, so, I mean, I don't know.
So, anyway...
It's pretty crazy, because, I mean, just me bringing that up and saying, owning up to it, saying, I'm really sorry, but I think I was that producer that you hated that got you involved with the flat Earth, and, and then we talked about it, and, we were starting to become pretty good friends by that time. It was before SkyTour LiveStream, but
Yes.
a few of our friends watch. Well, P&K watch the moon mainly, and Bill Skywatcher watches, just the
Meteor
main sky, not
showers.
any deep sky images like this,
Yeah.
but just the overall sky, usually meteor showers and stuff.
Right.
I think he's still streaming now, so those that don't want to go to bed after this, hop over there. But yeah, and then they kept saying, Mark, you got to do this. You got to do this.
Yeah,
And then
they're the reason.
he just kind of. Well, I think before I asked you, or before you asked me, I think anytime I saw a question, I was just sending it to you on Skype. And you said, well, why don't you join the call? You can keep your eye on chat while I am watching the sky and the equipment and stuff. And
Yeah.
he used to be physically outside in the dome.
Oh yeah, in
moving all
20-degree
this stuff,
weather.
so-
Yeah, it was really. Back then it was not like it is now. I've automated everything to because of the goal down the line. You're right, Amanda. But we had and then it was Keith and Paul from P&K Space Imaging and Bill. They encouraged me to actually stream. And SkyTour LiveStream wouldn't be here without them because I did it on their with their encouragement, and that's actually kind of cool. And look at it now; it's grown to 2 locations soon, and we're actually talking about a 3rd location. By the way, just little secret info there.
Here and there, yeah.
Talk about 3 potential, and so. And then, thanks to Bill Skywatcher, I ended up becoming a KGRA host as well with SkyTour Radio. And of course, when Race heard from Bill, who said, "Oh, Race, you gotta get Mark to do a show on astronomy." Ray said, "Oh, that's a great idea, brother. Let's do that." And then I got calls from them to say, "Oh, you gotta do this. You gotta do this." And I really wasn't sure that I wanted to. And so I started with 8 to 9 p.m. on Sunday night. Actually, a very good prime time slot. And then people just said...
Well, before that, when you weren't sure if you wanted to do it, you said you asked Race if I could be your co-host.
I did. Exactly.
And then basically the audience pushed and fought and demanded that we take a second hour.
That's right. The people
and
watching.
They did. They actually rescheduled a very popular show that was on before us.
Yeah, they moved.
Thank you to Commander Cobra who made that adjustment.
Yeah, the commander's a very, very good friend of mine. One of the most amazing people on the planet, and his show was from was it 7 to 8 or 8 to 9?
His was 7 to 9.
Oh, right, 7 to 9. That's right. And ours was 9 to 10. No, 8. 9 to 10. Right?
I think so.
Yeah, and then we ended up. He ended up going.
He moved an
6
hour
to 8.
earlier so we could take. What it would have been his last hour was now our first hour.
Yeah, and we ended up going from 8 to 10. And again, that's because people were clamoring for it, I guess. You know what? I love the fact that people want to learn science. And that's why I do all this. That's why I spent the effort and time to put all this stuff together. And, there's nothing hidden in secret here. And if anyone has any questions about how it all works, I'll be happy to show you. All the software that I use to run SkyTour LiveStream doesn't cost me a dime. It's all free software. I was determined to do this in a way that other people could also do it. And, there's a few things. I mean, obviously the telescopes cost money and the cameras cost money. And the concrete, the pour foundation that we did out there. I mean, all that stuff costs money. But, and there's more to spend. I mean, the building costs thousands of dollars. We had to buy that. Well, we did that using a GoFundMe. The GoFundMe was very successful. Hey there, Genghis. You've been listening, but you said something earlier today. So anyway, it was a really, really successful campaign. People want to hear about science. They want to learn. I was like, wow, that's very cool. I'm very humbled.
Well, we did. I mean, I don't want to sound like braggadocious or anything, but we did very well in the ratings right from the get-go.
Yeah.
I mean, we were consistently in the top 5 almost every week. I think that had a lot to do with us getting the second hour.
I think you're right. You know, and we've had ratings as high as 2, and it usually averages 3 to 4.
And I mean, it's a paranormal network. I personally find they tend to focus more on UFOs, and then we're like really one of the only science-based shows. So I mean, that says a lot, you know. I mean, it still has to do with space and stuff, and the possibility of life elsewhere comes up and things like that. But
Sure.
People love it. They really enjoy it, and it's accessible.
Yeah.
You know, you can get your questions answered right away. You can be part of the conversation, and I think it's just amazing. I think it's wonderful.
Yeah, people really enjoy it. You know, I'm very pleased that we have those people that enjoy it, and then we have special co-hosts from time to time, like Carol Carl behind the Obsidian Curtain, Friday nights at 7 p.m. on KGRARadio.com. You know, Carol's still with us, right?
Oh, yes, I'm definitely still with you, and so honored to be part of this because, you know, it is, it's like fleshing out my education.
I hope the story was worth it, Carol. Did you enjoy that?
Oh, indeed. I love it. I love the history because, you know, a lot of that is stuff to which I'm not privy. I was doing, you know, paranormal news update for KGRA for a long time. And then along came Behind the Obsidian Curtain. And all of this is due to my past connection with Bill, who, like, wow, way back from, you know, Inception Radio Network before that all fell apart. And Bill had always said to me, you know, he left way before that disintegrated. And it was like, hey, Carol, if you ever want to, you know, and oh my God, so here I am now. Yeah.
Love that. Bill is the man.
He is,
and
indeed.
I'm going to put that link in chat again for those that cannot sleep.
Yeah, right.
Very good.
Hold on, run link.
I've cut over to my cell phone so I can go outside and shut down the observatory, and people watch me go in the observatory now.
Indeed. Here we go.
It's all shut down though, so I gotta put on my red light though. I gotta have a red light I have to put
on the red light.
Put on the red light.
Yeah.
Put on the red light.
Griffin on a Santa Ana, indeed. Oh my gosh, so yeah, right. Yeah.
Holy cow. Oh sure. And now where we were looking, it's clear at the moment over there, but crap. I hate that. Oh, but there's clouds though, so I don't feel bad about having to shut down. Alrighty. Okay. Alright, all shut down there.
Like a miner in there.
Can you see me?
Yeah.
Oh no.
It looks like a miner's hat with the little light in the front. And that is Mark D'Antonio himself.
Yeah. No, just see, this dome is not automated. It's all manual. I don't like it.
And how tall are you, Mark? 5'10", 5'8", 5'10"? And so how much taller is that than you? Do you know how tall it is?
Yeah, the telescope is just about sits at about 7 feet. Yeah. Oh, my head. 7 feet at the top. So it's.
You said that's when it's sitting, like in its resting position now?
Yes.
It's 7 feet right now?
Yes, up here is the top of the telescope. I can barely reach it.
And I see that.
Yeah, can you see it or no? Oh, you probably can't. Okay.
I can see what's going on.
And that's a 7 foot.
Putting the lid on.
Yeah.
So when it's standing up at its tallest, how tall is it? Do you know?
going to be automated. I got to know the automated.
Can you hear me?
Yeah, I hear you.
How tall is it standing up at its fullest?
Probably around 7.5 feet.
Okay, your video just paused.
Okay, I could tell you that's probably just a. Oh, I see what's wrong here. I can hear you. Can you hear me?
Yeah.
Okay.
It just the picture froze though. It like paused. Okay. Yeah. That's okay. We can hear you.
Well, we're all closed in down here and down there. You can't really see what's going on back here, though. I can't. But this part here is the filter wheel, and behind it is the camera that's permanently attached. But that's it. I'm out of here now. And I can lock it up, go back in the house, and then we'll be done. I got wind. Oh, and I also, my dome camera has got some haze on the inside too, moisture. I hate when that happens.
Kyle wants to know if you use a laser photometer as well for observations for a filter.
I do not use, I do not use a photometer. I used one a number of years ago. I had a photometer that I used for doing stellar studies, but I don't have one now. They're very temperamental and require a lot of calibration, which is fine, but it's just that I don't have one. You're gonna hear an echo now until I get my thing here. So, 1 minute. 1 minute. Okay, so now I should be back. I should be back now without any echo. Yeah?
I never heard any echo.
Oh, okay.
Oh, looks like the camera's live.
Yeah,
I see your mouse moving.
It actually timed out a little, so I think that's what the problem was. Okay. Well, there we go.
So we're all closed up.
We are. We're all closed up for the evening.
Safe and sound.
Yep. And those caps, those covers, those are the things I was telling you. Those will be automatic. Those are going to be automatically placed onto the telescopes. You can actually see the top telescope right up here. There's the top telescope, and here's the bottom telescope. And on top of this telescope, at the back end, there's another telescope that sticks off and aims forward. And that is integrated into this upper telescope. It's part of that upper telescope, part of the guiding process. It's an auto-guiding system, and it's really, it's really something that's needed, because then I can do multi-minute exposures if I want to. And in Arizona, where the skies are just dark, we won't get light pollution. We will get star pollution. Yeah. I want stellar pollution. I don't want anything else. That was very nice of you to put that in our chat, Amanda.
What?
You put the did you want to put that link in the where'd you want to put that link?
Which one?
The SkyTour LiveStream. You in our Skype chat you put something.
Oh, I know. I meant to put it in chat. I accidentally hit it in Skype, and then I went over and put it in chat.
I know worries.
That's our Facebook page.
Yeah.
That people too. Yeah. Actually, when I went over there to get the link, a few people were waiting for approval to join, so I accepted about 5 people. So if it was pending, I'm sorry, I didn't realize. I didn't get a notification that people were pending. So, and Kyle Lynch was one of them actually. Okay. I did notice that name. I think I noticed another name that was here tonight, but I forget it now. Right. So yeah, if you are over in Facebook, I can definitely post that link again.
Very cool.
Facebook, highlight. Yeah, all the pictures that Mark takes here on the live streams, he processes, and well, not all of them. Sometimes he puts raw ones if you want to play around with them, but he'll post a bunch of the images he took on previous live streams, so you can have them or look at them or play with them if you want to, like the raw images, if you want to toy around with them yourself.
Yeah, I do that for people who want to actually do their own processing.
Yeah.
Hold on one second. I'll be right back.
Anything you'd like to say, Carol?
Of course.
Or are we eavesdropping on Mark?
I'm on mute here. I'm just kicking back, appreciating the incredible education here that's available. Yep.
Sorry about
I
that.
mean, it's pretty convenient to be friends with an astronomer, I gotta say.
You know,
Not trying to make anyone jealous out there, but
no, but oh my God, what a privilege.
No.
here's something crazy that you want answers to. Because, and I've said this before, I may have said this the other night, I have a hard time watching those kind of shows on my own because I have questions and you can't really ask a TV or a computer. Like, you can Google things, but then sometimes the definition, you have more questions than answers. And then the more you know, the more questions you have, you know, the more information you gather.
Yes.
And it's so much more convenient to have someone that understands it and can dissect it and explain it to you, and, you know, like,
and is willing
I've asked Mark questions that aren't, like, physically possible, you know, that just, they don't kind of equate to each other, like the things I'm trying to equate to each other, it doesn't make sense.
Yeah.
So, you know, you have to have such a good understanding that, you know, how can I explain it when you're so far off the course, you know?
Yeah,
which I usually am.
No,
too, my dear.
You're not usually that far off, Amanda. You actually have a very good fundamental understanding, more than you think you do.
Well, if I have time on my own, I try to think things through, you know?
Yeah.
But then sometimes, like, if a question is posed to me, like, on air, I don't want there to be a whole bunch of dead air. So sometimes I'll say something, like, instinctively, and then the more I think of it, I'm like, no, hold on a second, I could have figured that out myself, you know? If I had thought about it more. Or an idea will strike me as, you know, so fantastical that my mind starts racing, wondering all these possibilities, but I don't know enough about it to know how to phrase it, you know?
Yeah.
So it's like talking to a 2-year-old. It's like, well, why not? Well, why? Why not? You know? How can we do this? Is that possible?
Well, see, that's the thing. You know, if it can't be explained in a way that you can understand it, then that's not your failure. That's my failure. That's the biggest problem with science it's being taught in schools, is that it's not being explained in a way that they can grasp in some cases. And I have a big problem with that. Always have. And that's why I think that I have the same outlook that folks like Neil deGrasse Tyson have, you know, with trying to get schools to just change their curricula to reflect the needs of people that need to learn a different way. I've always done that. I've always been someone that wants to help people learn a different way, the way they need to learn, you know, and that's something that I've always done. I've taught, you know, throughout the years, I've taught gifted students, I've taught challenged students, you know, physics and astronomy, and you don't know what it's like to see someone who is considered a dismal failure in their own school come away with a real understanding of physics, because you figured out that that's the thing they're good at. And when you're good at something like that, you're probably not going to be very good at other things like socializing. So you'll be marginalized. But when you figure out that you're good at that and you give that kid a weapon now, which is actually science, holy cow, you watch them turn around. You watch them become a whole new person. And I did that for a number of years too, you know. So I know what it's like to be asked questions that seemingly should be understandable intuitively, but aren't, because the answers aren't being given in a way that the kid, the child, the person, the young adult even would understand, because it's not being spoken in their particular quote-unquote language. Say it in their language and they get it, you know. And that's sort of my philosophy, right? So that's what I like about it, and that's what I like about this whole SkyTour LiveStream. It allows me to just take a telescope, and man, it just turns into a whole new world, you know. So enough
and another
of that.
excellent teacher who just showed up in chat.
Daryl, yeah.
Daryl.
Daryl's our co-host as well on SkyTour Radio.
I love his analogies, I gotta say.
Yeah,
he really brings it down to things that people can relate to.
Yeah. Yeah, Daryl, you just missed us. We stopped looking at the sky about an hour ago. We actually we had clouds.
We have time for one more question, and here we are an hour later. Yeah. I didn't realize. Sorry.
Yeah, and I do have to close up. So I mean, it's already closed up, as you can see on the screen. But it's time for me to actually hit the hay, because I'm going to be up early tomorrow. You guys, Amanda, thank you for joining us when you did.
Sorry, I missed your message. I'm surprised that the message came in so late, actually. But hey, you have the opportunity, take it.
Well, the thing was, it was torrential rain.
So cool to be part of this as well. Yeah, wow.
Yeah. No,
and hello, Daryl.
I'm glad you could come along, Carol, tonight.
Thank you.
Yeah,
Thank you for being there, so Mark wasn't alone, Carol.
Oh, hey, thanks for inviting me.
Well, you're more than welcome, Carol. You're always worth having on board.
Bless your heart.
Yeah.
And check her out on kgraradio.com on Friday nights at 7 Eastern.
Yes.
Yeah, because it's 8 o'clock my time.
Yes.
Behind the obsidian.
Thank you, Amanda. Thank you, my dear. You bet.
Yes, of course.
It's Behind the Obsidian Curtain with Carol Carl, Friday nights at 7 p.m. on kgraradio.com. Your only source for paranormal and astronomical phenomena.
Indeed.
It used to be paranormal phenomena. Now it's paranormal and astronomical.
Hey, I somehow think that the two are connected. We'll find out, in decades to come how they're connected. But I think there's an overlap.
Yep.
I saw a few people in chat are on Discord. KGRA is on Discord, and you can join our chat there. I'm always in there Sunday nights when we have a live show, and again, just like this, we take live questions. We do have a phone-in line that usually opens the last half hour. It's a 2-hour show, so definitely consider, if you like what you hear, come over and
think of if you like SkyTour LiveStream, where you see the visuals and the imagery. In SkyTour Radio, it's on the radio, but we try to paint a vivid picture, and we're moving toward, and we did this once already, we're moving toward a format like SkyTour LiveStream for SkyTour Radio, where you'll actually be able to watch SkyTour Radio at the same time as hear the radio. So it's kind of it's sort of like I won't call it a lecture series, but kind of like a fun class, one that everybody wants to get into,
Exactly. I love that. It's a great concept.
Yeah, it's kind of cool. And I want to just say hello to, I see Risa's here. Tara, I don't know if I think I said hi to you before, Tara, but thank you. Tara D, she's actually one of the editors. She's actually the editor, the main editor of my book. So I just want to thank her for, all that work publicly. She's really good. And she's also helping at the SkyTour LiveStream West facility.
Outstanding.
Yep. Great person. And Risa, hello, and I see you. That's a new face for me, is Risa. I haven't seen you here before, so I appreciate you coming on in to see what it's all about. So I would like to take this opportunity to thank all of you for coming out and hanging out with Carol and I for the evening, and then with Carol and I and Amanda for the end of it. As you can see, the telescope is shut down. We have clouds and turbulent sky, and we got some really nice shots of the comet, but we'll get more the next time. So you guys, you have a good evening, and we will be back at you again. So until next time, until the next clear night, just remember, when you go out, you keep looking up, okay?
As Amanda says, unless you're driving. Okay. Good night, everybody.
All right, guys. We'll see you later.